Good evening, all. So today we are going to finish our software engineering. So I will just go through very quickly the overview and then go through the note. Okay, right? Testing, and if we have time, we are going to do past paper, last year past paper as well. Okay, at least start the past paper. Okay, right? Software testing and evolution. Okay, I will be just giving a brief overview of what we discussed so far as well, because sort of a quick revision. Because I just want to put you into the examination mood. Okay, right? So when it comes to, so I'm just giving the first few topics also a little bit of a revision as well, right? So this topic is software engineering. So software engineering is how to use engineering approach in software development. So why do we need engineering approach? Because developing software is a complex task. So when we have complex tasks, technically complex tasks, we approach it by engineering approach. So what is engineering approach? That is, we analyze the problem, we design a solution, develop, test, and evolution. So that is how engineering work. Okay, right? So then we took one by one, starting from analysis, designing, development. So today we are going to do the testing and evolution. Okay, right? So in engineering, the very important concept is modeling. Very important concept is the concept of modeling. So we use modeling in two places. In analysis, we use modeling. We model the requirements. In designing also, we use modeling. We model the solution. So likewise, you must have a very clear idea. So then you don't have to memorize, right? So you can just relaxly go and face the exams, right? Without any stress or whatever, right? Right. So we model in the analysis, and also we model in the designing. Okay, right? So modeling is extremely important concept, right? So then we took one by one, starting with analysis. Okay, so when it comes to analysis, what are the key tasks? So the objective is understand and model the requirements. Okay, right? So the challenges are, there are ambiguities in requirements, and also there are changes in requirements, and of course the requirements can be quite complicated as well. So those are the challenges we are having in requirement analysis stage, right? Right. So how to tackle that, or what is the approach? We gather, right, analyze, model, document is actually part of the modeling, and verify. So that is the approach. We gather requirement, different techniques we discuss, starting from interviews, questionnaires, observe, have some joint application development sessions, so meetings, right? And study existing systems, study similar systems, or even, right? So that is gathering. So then we have to analyze. Analyze means we have to look at the big picture, then break it into components, then how these components are interrelated. Are there any generalization, specialization? So that is, looking at those things is called analysis, right? Requirement, not a solution. And we can model those in a different models. For example, if it is structured system analysis and design, we can model data aspect separately, process aspect separately. Data aspects, we have the ER diagram, analysis ER diagram, right? So diagram like this. So then for process, we have context diagram, data flow diagrams, level 1, level 2, etc. Right? Then even for low level things, we can have even process descriptions. We can use pseudocode, structured English, things like tree diagrams, etc. Okay, so that is process structured way. If it is object oriented way, the main diagram is use case diagram. where we have actors and use cases, right? And use cases can have some relationships, right? It includes, extends, etc., etc. And also there can be use case inheritance, use case actor inheritance, etc. So that is modeled in the object-oriented way mainly. And of course, we can use some other diagrams like activity diagrams, sequence diagrams, etc. Okay. Uh, I show that there are some object-oriented diagrams also they have asked. What I can do is I can share you the object-oriented SAD note for the semester 3 students. You can just quickly go through that note, which will be really helpful when you are going for the software engineering paper. Okay, I will be sharing it right after the session or during the break. Okay, right. So there we discuss in lengthy way. You don't have to go into details. Just have a brief look at, just rush through the note only. Okay, right. So then we have to document it and verify it. Why we want to verify it? Because this is our understanding. We want to double check whether our understanding is correct. We have to give it to the customers or the clients and verify it. And sometimes it's a logistical requirement, legal requirement. In case of an issue, we have a sign off requirements agreement. So then we can say we have implemented this. Okay. Right. So that is analysis. So then the design. So designing is modeling the solution. First come up with a solution or different various solutions, and we can model it as well, and we can review those models, refine the models, and sometimes we have to pick which is the best model, etc., etc. So that is designing, right? Come up with solutions and possible solutions and pick the best solution and refine it. Okay, so when it comes to designing, we have the high level designing and the detailed designing. High level designing is sometimes called architecture, right? Architecture. So whether we go for web architecture or the 3-tier architecture, standalone application, peer-to-peer, so likewise, so layered architecture. So there are different architectures, right? Repository architecture, client server architecture. So you should be aware of those things. Okay. And since we have done doing the web development also, so you must have some very good understanding about these things. Okay. Right. So then detailed design. So there we can subdivide those aspects into different levels as well. For example, program design, database design, okay, UI design, system interface design. This is user interface, right? System interface design if you are integrating with other systems. Okay. So those are, we have to do those in detail level. Right? So program design is the main thing where you have to draw class diagrams, sequence diagrams, depending on the complexity. Okay. Object diagrams, state diagrams, etc. Model the solution so that the development team can understand the solution. Otherwise, how can they start coding? So then the database side, so we have to map our entities and relationships into tables. So the relations and relationships, right? We have to identify, sometimes we have to map associative relationships into tables, right? Multi-valued things into the separate tables, blah, 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 which we discuss under databases and normalization, etc. So that is database designing. Then UI designing, user interface designing. Anyway, we have user interface designing as subject in your semester 4. So we have to design, there are some concepts, right? Consistency, simplicity, some psychological aspects, etc. Right? So we have to consider those. And the system integrations designing, like whether are we going for web services, enterprise Java beans, or how are we going to communicate with other systems? Is it as a SOAP messages, HTTP messages, or JSON objects? So there are so many concepts which you will be which will be covered in your level 2 again. In semester 4, you have a subject called enterprise application development, right? So those are the different aspects of designing. And there are some other concepts as well, like design patterns and blah blah blah, which we discussed in the previous session. Okay, so that is designing. So then the development, right? Development. So we took development and design pretty much together, right? So in development, of course, we have to develop the system. So develop the system in the sense we have to develop the database, we have to develop the program, right? Of course, we have to develop the UI and other integrations we have to do. So then our system is gradually getting ready. So that is called development. So it involves a lot of coding, right? A lot of coding. And also we have to do a lot of unit testing during development. Okay, so our software developers, software engineers are busy building the software system. Okay, that is called development or development task. Okay, so then we have the today's topic, the testing, and finally evolution. Right, now let's look at what is testing is. What is testing is? Right, testing is check whether the product that we are building and the product that we have built, is it doing the expected functionality. So you can look at it in different ways. Testing. So one way of looking at testing is right. So I hope you can hear me because I had a power cut now. I'm having a power cut now. I hope you can hear me. Right. Right. So testing, you can look at it in different ways. Right. Just give me 1 minute. Right. So one way of looking at testing is check whether your product has the required functionalities or meet the functionalities. So that is one way of looking at testing. Another way of looking at testing is check whether are there bugs. Okay. So likewise, you can look at the testing in different ways. Or check whether it has your product has met other objectives. Because a product has so many objectives, right? Performance objectives, usability objectives, etc. Okay. So that total task is called testing. And testing is a collective effort. It's a team effort. The responsibility is for entire team. It is not testing is the responsibility is only QA engineer or the tester. No. The more responsibilities with the developers, and then your QA engineers or the testers. Right? So don't think that it's only testers or the QA people doing the testing. No, good part of testing is done by the developers. Right. So when it comes to testing, we can look at different type of testing. So this is in general the testing approach, but this vary depending on the type of testing. Okay, depending on the type of testing. So therefore, let's look at what are the type of testing first. Right, I'm doing it very fast today. So therefore, if you have any questions, you need to ask. So one type of testing is called unit testing. First, I will list down, then I will take one by one. Okay, unit testing. So then we have integration testing. So another type of testing is system testing. System testing. So this is unit or module testing. Okay. Another type of testing is user acceptance testing. I will just write it as a UA testing, user acceptance testing. So those are the four main type of testing. Okay, four main type of testing. So other than those four type of testing, there can be some other testings like performance testing, load testing, usability testing. Right? Then there are some other testings like smoke testing. Right? So those are some different testings. Okay, right. So let's take one by one very quickly. You have to refer to your note. I'm just giving you the overview only. Okay, right. Unit testing means when you build a particular functionality or unit, right? While we are building that, we have to gradually test it. That is developer's task. And so let me explain one more concept and come back to this. In a different way, we can subdivide testing into two types. This is a different categorization. That is glass box or white box testing and black box testing. So glass box testing means when we are testing, the person who is testing is aware of internal logic and other things, and he tests that functionality or the developed product with knowing how the things are internally happening. So then we call it white box or glass box. Now your software is like a glass box. You know how the things are happening inside. So therefore, you know, you want to test those specific things, whether it goes to the else part, whether that loop is executed, etc., etc. So that is called, if your target objective is to check those, whether those development activities are properly executing. So that is called glass or white box testing. So typically, or in not just typically, in general, glass box testing can be done by developers. Obviously, why? Developers are the people who know the coding because they are the one who code it. So others, they can't just look at the code and understand the software, right? Maybe they can understand a little bit of, but perfect understanding is with the development team because they are the one who developing it. Remember, this is a complicated thing, right? Software is not a, now can you think, do you think that you can go to a, you can just go to a something like ship or aeroplane and understand how it is working? But those who build it, the aeronautical engineers, nautical engineers, they can understand it. It's something like same thing, right? So software engineers build it, others can't just come to the look, open the code and understand what is happening. So therefore, glass box or white box testing is typically done by software developers while they are developing the mostly while they are developing. Okay. So then black box testing is, you consider software or the module or whatever as a black box. You are not aware of internal things, so you don't care. You just check whether for correct input, are we getting the expected correct output? That's it. So then we call it black box testing. Okay. Right. So some of these testings are white box or glass box. Some of these testings are black box. Okay. Right. Unit testing. So unit testing is definitely a glass box testing done by software developers. So unit testing means when you develop a particular functionality or unit, you immediately test it. Actually, not immediately. While you are developing, also you are gradually testing. Okay. So that is called unit testing. Right. Because if there are unit test failures, the developers can quickly fix it because they are fresh. They fresh, you know what is what they are writing, and they can while they are developing, they can fix those issues. Right. So that is called unit testing or the module testing done by developers, and it's a white glass box testing. So then the integration testing. So when the modules are now gradually developed, they start integrating those modules together, because you have to work, your system is not just isolated modules, your system is collaboration of these modules. So therefore, the development team is going to gradually integrate those modules together. Okay. So then they have to test whether the integration is properly happening, right? Whether these two components are properly now communicating with each other, collaborating with each other. So that is called integration testing. Again, it is mostly done by developers, and it is again a glass box or white box testing, because they know how it is supposed to be integrated. So then they can specifically test those scenarios. Okay. So that is integration testing. Right. So the third type of testing is called system testing. This is the most widely known testing, and this is typically done by the QA people. Initially, system testing is done by developers, but bulk of the system testing is done by quality assurance or the testing people, and it is a black box testing. It's a black box testing. Now they are going to test the system. Now the modules are there, they are integrated, unit testing and integration testings are done. Now they are checking different functionalities and see whether the expected output is given. So that is called system testing. And if there are bugs, the QA team is going to put up some bugs and assign to the development team, which they have to fix it if it is a genuine bug. So that is system testing. So usually the development team will give QA releases to the QA people, and the QA people are going to do it in a traditional environment. Okay, but in an agile development environment, so these things are also happening sort of parallelly as well at the latter part of the iterations. Right. So now once your system is properly tested and the QA people are confident that now the system is stable, now we are ready to release it. And now it has to be tested by end users or your client. So that is called user acceptance testing. So every release before going into the production, it has to be approved by the client or the customer side people. So they will also do a testing. It's not a very comprehensive testing, but they are going to test the basic flows. Of course, they are going to trust us, our QA team, because our QA team has done comprehensive testing. So therefore, they are going to do some basic testing and see, are they happy? Just to check whether the functionalities are working. So that is called user acceptance testing. If the user acceptance testing pass, only that release will go production. Otherwise, that particular build is rejected by the customer. So then you have to fix those issues and give another release, maybe next release or whatever. Okay, that is called user acceptance testing. And at the very end of the software development cycle also, there's a user acceptance testing. That is the final set of testing that they do and accept the product before closing the project, development task of the project. Of course, the maintenance and other things will be there, but the major development will be then closed out. Okay. Right. So those are the main testings, right? Unit testing, integration testing, system testing, and the user acceptance testing. Then there are some other type of testings as well. Right. So that is where we have, especially we have the performance testing. So performance testing means we have to check whether the system has a reasonable performance. Especially we look at two things: the time. For example, when a customer search for a particular product, how long it takes to get the result to the screen. Say web application, if it takes 30 seconds, that is not acceptable in most of the time. So they will say, okay, we need to get the results to the client machine within maybe 6 seconds or 7 seconds. Or maybe sometimes they will say 3 seconds. So if it is not meeting those objectives, so that means there are performance issues which we have to fix, optimize. So that those testings are called performance testing, especially the time. Not only the time aspect, we look at the resource aspect as well. If the system is taking too much of memory, too much of processing power, that is also not good. So those kind of things are tested, or doing those kind of testing is called performance testing. So then we have the load testing. So load testing is a special kind of a performance testing. So load testing means we test whether the system properly work under heavy loads. So this is not done by all the software. This is not needed for all the software development project, but it is needed in some cases. Like if you are developing that system for, say, bank, we know that thousands, not thousands, sometimes even 100,000s of people are accessing the system at the same time. So many transactions in all the branches, ATM machines, online banking, right? So then how does our system going to perform under heavy load? So that is what load testing is. So there are some tools, load testing tools, where we can apply load using software. We can say concurrent, parallel, 1,000 users accessing this particular these and these functionalities. So then the tool is going to apply that load, right, by automating the testing. So that is why QA engineers also need some programming knowledge, so that they can write or automate those testing and apply the load. And then they monitor whether what is the response time, right? How much of a memory is consumed in the server? Are they going for memory out of errors, right? And things, or is it going to hang, right? So those kind of things are monitored and reported. So that is called load testing. So performance testing is usually under normal load, but here we apply big load and testing, but both are highly related testing. So then we have the usability testing. So usability testing means we test for user friendliness. How is ease of use, right? So we are paying a lot of attention to this topic when we are doing the user interface, UAE, user experience design subject in your level 2. So it's a separate set of testing, and we have to look at it in a very different ways and different mindset. It is not just to test the functionalities. No, we test for different type of users, how they are going to feel it. So that is called usability testing. Okay, because it's a high competition. Maybe your competitors' system is much more user friendly than your system. So then people will go for that. Okay. Right. So then there's another type of testing called smoke testing. There's another name for smoke testing. The proper name is, let me do a Google search because I forgot the, it's a technical term. Yeah, sometimes we call it sanity testing also. Just give me 1 minute. Anyway, let's say whether your slide has the name. Okay, and the proper, there's another name, I can't remember. Okay. Yes, but I will explain the concept. Right, smoke testing means usually now when you say we have given a release, say last month. Now at this end of this month also there's a release. Okay. Now before the QA team start doing the system testing, that is what their main task is, right? They will do a quick testing on the release, right? Quick testing just to check the health of the product build, because there can be some issues, right? When you are doing some changes, major functionalities maybe, right? So you may introduce some issues to the main functionalities, because it's human, right? Software developers are, of course, they are very disciplined, but there can be some possible issues. So then the QA team, before starting their, yes, so that is a word, right? Thank you. So we call it regression testing. Yes, so that is the technical term we use. We call it regression testing. So we do a regression testing or smoke testing. Okay. So smoke testing or regression testing means we just go through the main functionalities. Just one of the QA engineer can do it. Okay, one or two of the QA engineer, they will take about half an hour and they will go through the main flows and see the health of the system. If they find that okay, there are some critical errors which they cannot proceed further, then they can reject the build without doing the system testing. So that is called regression testing or the smoke testing. Okay, right. Right, so those are different type of testing that we do. Okay, so the main category glass, white box and black box, and some other specific type of testing, and it's a team effort. It's a team effort. Right, now I'm going to explain you the testing process. Test process. Right. It depends on the type of testing, whether it's unit testing or system testing or usability testing or whatever. But I'm just going to give you an overall approach. But this is more relevant to testing like system testing. Right? This system testing. Okay, so this is more relevant to this system testing because, for example, unit testing, it's very casually we do, software developers. Okay. But unit, the system testing and the especially user accepted testing is a very formal testing done by the QA people. So when it comes to that kind of a testing, this is the general task. Of course, first of all, just like the software developer must understand the requirement, your QA engineer must understand the requirement. How can you write a test case or do the testing without you don't understand the requirement? So therefore, it's not only the development team. At the initial stages, the QA team is also studying the requirements because they also have to understand the requirements in order to do the testing. So then once they understand the requirement, they write the test cases. This is for system testing. Okay, write the test cases. So they write down, this is the title of the test case, and we are going to test this functionality, and these steps we are going to follow, and this is our expected output, or these are our expected outputs. So it's time consuming and very sort of a boring task. Okay, very boring and time consuming task that QA engineers have to do, right? Writing down the test cases. So then when they get the QA release or the release from the development team, they are going to test it. How to test? They are going to execute the test case, right? Execute the test case, and they are going to check whether if it is passed, we say that test case is passed. That means things are happening according to the expectation. But there can be some issues like you get a certain error or you get output which is not expected output, right? So it's not only errors. Sometimes there are no errors, but the output is different. So it is after that it is supposed to add that amount to the say account, but it is not happened properly, or maybe there's a it is supposed to debit 1,000 but it has debit only 900. Maybe there's a bug. So in that all those situations, they say the test case is failed and they will raise a bug. We call it a bug. The QA team or the person who tests that particular test case will report a bug and assign to the development team, which they have to fix in the next release. While they are testing, you can't do it for the current build. So then it has to be fixed in the next release. And in the next release, the QA team is going to test that test case again And if the bug is fixed, they will close the bug. Otherwise, they will just keep it open, right? So therefore, you test it and you document the test result. And document test result that includes raising bugs in case of a test failure. Okay, so that is the general steps. Write down the test cases, test, and document the result, and you can generate some test reports, etc. Okay, or you can, if you want, you can take that to also generate test reports. So by looking at that, we can decide whether the release is stable, whether we can release to the customer, or do we have to do some more bug fixes and changes before releasing to the customer. Okay, right. So I hope you have some idea about the testing process, as well as different roles and different type of testing we have to do. In agile development, these things are pretty much done as a teamwork. There's nothing called QA engineers there actually. There can be 1 or 2 QA engineers, but usually the development team is and the QA team is heavily collaborating, and as a one team they do that. Okay, sometimes it is good the team member, two players are collaborating. Sometimes it is not good as well, because it is sometimes good that QA people look at the product independently. Then only they can see the issues that the development team cannot see. Okay, right. So now let's quickly go through your note, and because they have done a lot of changes to the note. Okay, that is why I wanted to take it back again, because in my login we can see all the other subject, but not the software engineering. They have not given access, I think due to some mistake by university side. Okay, so that is why I asked you to get it. Okay, right. So now let's quickly go through the university note for the testing. Okay, you can see the black box and white box, blah blah blah. Right, I'm going to quickly go through. Right, understand what is software testing and why is it important. Understand the stages of testing process. Identify how to select test cases. Right, I mentioned the word test case now. That will general to discover program defects. Understand test first development. Compare and contrast different testing techniques. Okay, right. So what is testing? I told you testing is finding bugs, checking whether the product is meeting the objectives, product is behaving or has the specific functionalities properly working, and any other things like usability, performance, etc. is called testing. Okay, right. So why testing is important? Otherwise, of course, if you release a product with the issues, not only we are in trouble, our customer is also in trouble. Then customers are also in trouble, right? So it's a mess. So therefore, it's very important we do a proper testing. Okay, so we want to deliver a high quality product, right? Very high quality product, right? So if you do a proper testing, there are a lot of advantages, lower maintenance costs, because during maintenance we are not going to face much issues. It is accurate, consistency, reliable, right? Customer satisfaction is also high, right? So otherwise we have to unnecessarily spend money for fixing those things and so many things. Okay, so injured and death means if it is something like a very critical software, like software developed for a vehicle, software developed for a life support system, so in that case, right, otherwise there won't be any injuries and death due to a bug in something like a banking system. Okay, right. Now you can go through the slides because I gave you the high level idea. Right, so you can see the input and output model of software testing. So you have to have the input test data. This is your program and your output test results. Okay, output test results. And if there are issues, you have to report them as defects or the bugs. Okay, right. So there are two concepts when it comes to testing. So this is very important thing: the verification and validation. Okay, verification, validation. Right. So basically, testing is validating. Okay, testing is validating. Validate whether the expected output is there. But verification is ongoing process. Right? For example, we can have coding standards. We can have peer reviews, reviewing the code. Right? The leader can, senior person can review the code, or peers, same level people can review each other's code. Okay, so that kind of, even we can review designs and other things. So those are called verification. So testing is pretty much validation. Doing other tasks for the quality assurance or maintaining proper quality is called verification. Okay, so if you do a proper verification in the validation process, you will be getting very little number of bugs. Okay, so therefore both are important. Actually, this is called quality assurance, QA. This is very much a quality control part. Okay, if you do a proper quality assurance, you will find less issues during quality control. Right, so you can see this definition is very interesting definition. Validation. Okay, are we building the right product? So that is why we want to test. We test and double check whether is it the right product? Is it the right product? Are we going to getting the correct output, or are we getting any errors? So that is testing. Right, this is testing. Are we building the right product? Verification, I told quality assurance. Right, it's an ongoing thing. So this is, are we building the product right? අපි හරි විදියට හරි ක්‍රමයට මේක build කරන්න යනවාද? හරි ක්‍රමයට කියන්නේ, are we following the coding standards, right? Are we following the best practices? So that is why we need a lot of reviews, standardization, etc. So if the team members are following those standards, quality assurance things, right? That means we are building it the right way. So if you build the product in the right way, there's a very high chance that we are building the right product as well. Right? So that is පොඩි එකෙක්ව හරියට හැදුවොත් එහෙම නේද? පොඩි කාලේ ඉඳලා හොරකම් කරන්නේ නැතුව, ජඩ වැඩ කරන්නේ නැතුව හරි විදියට හැදුවොත් එහෙම ඒක ලොකු නම හරි වැඩ තමයි කරන්නේ. නේද? හරි විදියට හදපු එකේ ලේසින් ජඩේක් වෙන්නේ නැහැ. ඒක පොඩි කාලේ ඉඳලා හරි හොරකම් කරන්න පුරුදු කරා නම් අම්මලා තාත්තලාත් හොරකම් කරලා අරන් එනවා නම් ඌට කවන්නේ ඌ දකින්නවනේ. එතකොට ඔන්න දැන් ඒ වැතවල ඊට පස්සේ මූත් ලොකු වුණාට පස්සේ නේද? දැන් මහින්ද රාජපක්ෂගේ පුතා ගිහිල්ලා හොරකම් කරනවා මිසක් ඌට කාලා බීලා හම්බ කරන් කාලා ජීවත් වෙන්න පුරුද්දක් නැහැනේ. So that is when verification is bad, the validation is also bad. Right? So because we are not building the product right, so then the product is also wrong. Right? So that is the difference between verification and validation. So we need both, because just because we do the proper verification, we can't automatically say that it is quality product, you don't have to test. No, still we want to test. Okay. Right. So that is called the V&V approach. Okay. V&V approach. Right. So you can see that the testing, some of the testings are more into verification. Some of the testings are more into validations, but actually in general, testing is more into validation, right? Whereas verification is more into the checking the standards, consistency checking, blah, 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 right? Those are more into the different verifications, okay? Testing is more into the validation. So actually unit testing is mostly done by you can see the white box testings are also, they have put up into the verification, but the final testing is pretty much customer acceptance testing and blah, those are the validation. Okay, those are the validation. Right. So verification is pretty much static, okay, like software inspection, review, etc. Whereas validation is pretty much dynamic, because that is where we test. Right. So I'm not going through each and every slide. Okay. So then the importance of software inspection and reviews, that is part of the verification. right? That is part of the verification where so there are two types of reviews, what is known as lead review and peer reviews. Right? Lead review means a senior person. Senior mind දැන් අවුරුදු ගාන ඉන්නේ මෙයා වැඩ කරපු අවුරුදු ගාන ඉන්නේ මිනිහාගේ තියෙන මිනිහා කරපු වැඩවල ප්‍රමාණය. හරි. එයා ඒ වගේ ප්‍රොජෙක්ට්ස් වල වැඩ කළා දක්ෂ කෙනෙක් නම් අපි යාට ලීඩර් කෙනෙක් කියනවා නේද? So ලීඩර් කෙනෙක්ට පුළුවන් ටෙක් ලීඩ් කෙනෙක්ට ආර්කිටෙක්ට් කෙනෙක්ට එයාගේ ටීම් මෙම්බර්ස්ලා ලියන කෝඩ් රිවිව් කරන්න randomly. Right? So that is called lead review. Because if there are issues, they can fix it upfront. So the other type of review is peer reviews. So peers means if you are a software engineer, I am a software engineer, I can review your code and you can review my code. So we are peers. So that is also very important because when we are doing complex things, there are high chance of making mistakes, or else you are not doing the best way. You are doing it, but that is not the best solution. That is not the best way to write that logic. So then also both lead reviews and peer reviews will detect those things so that we can fix. There are so many advantages in reviews. One thing is we can early find out any issues in the product. That is very important, right? Even before testing, we identify some possible issues. Number two is when we identify those issues, we can learn from that. Maybe I was not aware that this logic can be written in a much better way. That is why I wrote it in the other way. Now I can learn from my lead or even from my peer. So we can learn from each other, especially in peer reviews. We can learn from each other, and lead reviews, we can learn from our senior people. Right? Right. So why inspections or these reviews are important? We can surface those issues early. Earlier you find issues better because otherwise the cost is higher, and also we can improve, and also it create a very good collaborative, high quality culture in our development team as well. Okay. Right. So when it comes to testing or the validation, I told you, especially when it comes to system testing, we have to do it in a little bit formal manner. So we have to write the test case. Right? You නිකන් හිතේ software එක දුන්නට පස්සේ ඔයාලට හිතේ තියෙන විදිහට test කරන්න බෑ. ඒක ඉස්සෙල්ලා ලියලා තියෙනවා. Right? Test cases. So while the software developers are in the early stage of development, the QA team is doing the writing the test cases. Right? So test case has to be written in a way. Now you have in the final year, you have a subject called quality assurance. It's just one subject, quality assurance. So it's all about how QA engineers write test cases, what is their approaches, what are their expectation from QA engineers, how are they going to collaborate with the team members. So that is what that subject is all about. Okay, because if you take a software company, right, if there are 100 developers, there are at least 20-25 QA engineers. So those are also job opportunities. So maybe you are not that. So we have to be very honest, right? Not everyone is in the same talent level. Not everyone is good in everything. So maybe you like IT, but you are not that good in software development. So then you can go for QA track, quality assurance engineer, right? Business analyst. Maybe you are really good in your communication. You are really good in understanding business concepts. So then you can be a business analyst or QA engineer. So different set of common skills and different set of skills. Okay. But in order to be a business analyst, you have to have very good communication skills because you have to very closely communicating with your customers, get clarifications and gather more detailed requirements, because then you have to collaborate with the team members, other team members. It doesn't mean that the team members are not exposed. Team members are also directly exposed, but the business analyst is more exposed. He is dedicated working on the requirements. Okay, right. So when it comes to test case, I told you that we have to we have to write those things, especially for system testing. So every test case has a test case ID, test case title, description, what are the inputs, what are the expected outputs. So description means the the procedure. So we have to do these things, and these are the inputs, and this is the expected output. Right? The test case can be either pass or fail. If it is fail, a bug will be raised. Okay. Then we say there's a software defect. Defect can echo error එකක් එනවා. එහෙම නැත්නම් ඔයාලට expected output එක එන්නේ. So then both are defects. Okay. Right. So when it comes to testing, I told you we have the unit testing. Sometimes they have taken unit testing and component testing as two things. Basically, sometimes we just take both are together. So unit means a tiny part. Component means little bit bigger part consisting few units. And these components have to be interconnected to get the system. Or you just call them these are units, or these are units and these are components. Right? It is just the different ways of looking at it. Okay. So then the system testing is testing this as a whole. And integration testing is testing whether these units or modules are properly integrated. Okay. Right. Unit testing, it's pretty much done by developers. It's a white glass box testing. And it's very, very important to do proper unit testing so that we can fix the issues then and there. So the best time to identify issues is while you are developing, because it's very fresh and you instantly you know how to fix that. Okay. So that is unit testing. Usually you don't have to write test cases, but you have to write unit test code. So there are some unit testing frameworks. For example, Java, there's a unit testing framework called JUnit, where you can write test cases and call your methods with relevant input and check whether you get the correct output. And you can automate it also. Then you can generate some test results saying, okay, I executed 25 unit test cases, and out of 25, 23 pass, 2 fail. So we can incorporate it to the build. Right? So that kind of things are done in real world software development. So there's something called software build එක තියෙනවා. ඒ build එක run කරද්දී ඉස්සෙල්ලා software එක build වෙනවා, ඊට පස්සේ unit testing ටික run වෙනවා. Unit testing ටික run වෙලා ඒ ඔක්කොමත් එක තමයි ඊට පස්සේ build එක pass the fail කියලා report එකක් generate වෙනවා. Build එක pass කියන්නේ build එකේ මොකද errors නැහැ. හැබැයි pass වෙච්ච සමහරට unit test case fail වෙනවා. ඒත් unit test case fail වුණාම අදාළ developers ලා දන්නා මොකක් හරි අවුල් වෙලා තියෙනවා. අවුල් කියන්නේ ඒගොල්ලෝ කරපු changes වලින් වැඩ කරපු functionality ආයෙ දැන් වැඩ කරන්නේ නැහැ. So then they can immediately fix it. Okay. That is why unit tests are important. Unit test is we can automate that and incorporate it to build, so that always it's sort of a unit testing is happening every time someone build it. Okay. මේ software කියන්නේ මේ hello world එකෙන් එහා අපි මේ නිකන් classes එකක් දෙකක් තියෙන කරන්නේ. The real world software means there are thousands of classes. Right. So this is how you test individual functionalities. You can test the login functionality, maybe payment functionality. You can test whether you can add an order, right? Right. So this object testing is pretty much another name for unit testing, right? Because it's a very low level testing where you test a particular class and its functionalities. So most of the time you are testing these individual methods using some unit test cases, and those unit test cases are sometimes we call them or together we call them object or class test. But in general, unit testing and object testing is pretty much the same. Okay. Right. So as I told you, we can automate testing. I mentioned the word JUnit. Okay. So there are testing frameworks, right? JUnit for Java, NUnit for .NET. Right. So we can write your test cases and incorporate it into your build. Now we'll build එක කියන්නේ build එක කියන්නේ දැන් අපි software එක develop කරද්දී අපිට ගොඩාක් codes එකතු වෙනවා. හරි එක එක modules සමහරට තව 10 ගානක් classes තියෙනවා. මේක අපිට අර build කරන්න ඕනේ. එක එක modules තියෙනවා. මේ module අතර dependency තියෙනවා. මේක build කළා තමයි මේක build කරන්න පුළුවන්. මේක run කරන්න මෙයා ඕන. ඒව අපිට ලියන්න පුළුවන් build script එකක් ලියන්න පුළුවන්. ඒවට තියෙනවා tools. හරි and කියලා තියෙනවා. Maven කියලා තියෙනවා. හරි එතකොට අපි build script එක ලියලා ඒවට තමයි system engineers line. Right? So there's type of people called system engineers. හරි. ඒගොල්ලෝ ඉන්නේ ඔය වගේ වැඩවලට තමයි. සමහරට එක engineer කෙනෙක්ව දානවා දැන් මම work කරපු එක project එකක් හිටියේ project එකට වෙනම system engineer කෙනෙක් හිටියා. එයාට වෙන කිසිම software development කරන්නවත් වෙන කිසිම දෙයක් නෑ. එයාට තියෙන build එක බලා ගන්න එක විතරම තමයි. හැබැයි project එකේ හිටියා engineers 300ක් විතර හැබැයි. හරි. එතකොට එක්කෙනෙක්ව දානවා එයාට තියෙන තනිකර build එක මොන හරි build script හදන එක, build script change කරන එක, හරි build fail වුණොත් එහෙම ඒක inform කරන එක වගේ දේවල් තමයි එයාට තියෙන්නේ. So system engineers ලා. හරි. System engineers ලා වෙන system engineers ලා තියෙනවා system administrate කරන්න. නමුත් software development team එකකට අපි සමහරවිට system engineers ලා ගන්නවා. මොකද we can automate the building of our system and which includes running the unit testing and sometimes that full build take more than 1 hour. Build එක අපි රැයට දාලා යන්නේ. මොකද රැය 12 වෙනි ඔක්කොම developers ටික දීලානේ. එතකොට ඔක්කොමලගෙම එදා check in කරලා කියන යන test ටික යන code ටික මොකද engineers 100 200ක් ඉන්න project එක එදා දවස් ඇතුලේ සෑහෙන code check in වෙලා තියෙනවා product එකට. ඔන්න රැය 12ට තමයි අපි ගොඩක් අය ඔක දාන්නේ. මොකද රැය 12 අනිවාර්යෙන් හැමෝම වයි ගිහිල්ලානේ. හරි. එතකොට ඔක 12 ඉඳලා build වෙන්න පටන් ගන්නවා. සමහරවිට build script එක කරන්න යනවා පැය 2 3ක්. හරි. එතකොට ඔන්න උදේ 3:00ට 4ට විතර හැමෝටම email එකක් යනවා. build එක passed failed කියලා එක පැත්තකින් යනවා. අනිත් පැත්තෙන් unit test case කීයක් passed කීයක් failed. ඒතර උදේට එනකොට අපි ඉස්සෙල්ලා බලන්නේ build mail එක inbox එකේ තියෙනවානේ. බලනවා අපිට අදාළ අපි වැඩ කරන modules වලට අදාළ unit test එකෙන් fail වෙලාද ඉස්සෙල්ලා build එක fail වෙනා නම් උදේන් පාන්දර පළවෙනිට ඉතින් build එක fail වෙලා නම් අදාළ කෙනා ඒක fix කරලා දෙන්න ඕන ටක් ගන්න. නැත්නම් අනිත් පැත්තේ දාට code ගන්න විදියක් නැහැ. Then if there are some unit test failures, if it is something relevant to your coding, you have to fix those things. Right. So we can automate a lot of tasks. Okay. So there are so many tools like JUnit, NUnit, and build tools like Maven, Ant, etc. Okay. Right. So these are some more details about the unit testing. Right. So you can subdivide unit testing into partition testing and guideline based testing as well. Right. So partition testing means identify groups of inputs that have common characteristics and should be processed in the same way. Right. You should choose test from within each of these groups because sometimes you have to test those together. Right. Test those together because they are relevant unit test. So then the guideline based testing, unit testing guidelines to choose test cases. Guideline reflect previous experience of the kinds of errors that programs often make when developing components. So that is with the experience, we know that these kind of scenarios we have to test. Right. So that, because with the experience, we know that when you develop this kind of functionality, there are high possibility of these kind of failures can occur. So then we can test those things specifically because we know that there's high possibility of failures. Right. Right. So you can read out these, read those slides, okay? Because we have to do another topic also. Right. So these are some examples, test scenarios, right? When we say username, how many characters, right? If there are lesser number of, say someone says password must be this number of characters and these special characters must be there, blah, blah, blah. Then how are we going to test all these scenarios, right? So then you have to write down not just one test case, sometimes 10, 15 test cases to cover, check whether all these possibilities are validated and stuff like that, okay? Right, so these are some examples given. Right, so these are some general testing guidelines. Okay. Right, component testing means something little bit higher than unit testing. Right, I told you we can look at set of small units for a common functionality can be considered as a component. Say payment component. Right, order component, right, reporting component. So then we can test those components. Okay, components. Say logging component. So we can test the login component. We can test the payment component. We can test the order module or the component. Right. So I told you the interface testing or the integration testing. Interfaces hariyata වැඩද කියන එකයි බලන්න. ඊට පස්සේ interfaces වලින් හරියට integrate වෙනවද කියලා බලන්න. Right. So that is interface testing. The next level of interface testing is integration testing. So stress testing කියන්නේ අර මම කිව්වා වගේ performance testing වර්ගය load එකක් දාලා අපි test කරලා බලනවා stress කරලා stress කරනවා කියන්නේ ඒකට විශේෂම load කරලා test කරලා බලනවා මේක test වෙනවද කියලා ඒක load කරනවට අමතරව අපිට පුළුවන් තව වැඩ කරන්න ලොකු නම්බරයක් දාලා බලනවා නේද ඒ වගේ වැඩක් කරනවා හරි for example අපි password එකට සාමාන්‍ය password එකට අපි කියන්නේ ඉලක්ක අකුරු 5ක් 6ක් කියන්නේ අපි සමහරට අකුරු 50ක විතර password එකක් දාලා බලන්න මේක වැඩ කරනවා කියලා. So that is also stress testing. Right? That is also stress testing, right? Because there can be exceptional situations, okay? කවුරු හරි වැඩි හොඳට කියලා මිනිහා වෙන බයට හරි වෙන බයට මිනිහා අකුරු 50ක විතර password එකක් ලියාගෙන ඕක දැම්මොත් එහෙම දැම්මට පස්සේ ඕක system එක errors ආවොත් එහෙම වෙන්න බෑ. සාමාන්‍යයෙන් අපි දන්නා password එකක් දාන්නේ අකුරු 10ක් 15කට වැඩි දාන්නේ නැහැ කියලා. නමුත් අපි දන්නේ නැහැ නේ මිනි මිනිස්සෙක් ඉන්න පුළුවන් නේ. මිනිහා එන බයට හරි. Then we have to test that also. Right? ඒ what stress testing, right? So then we have to test some non-functional things like usability, performance, security. Security is in a way functionality as well, right? Right, so I told you the system testing is pretty much the most widely done testing and done by the QA engineers, and it's a black box testing. Right? You test different functionalities. So usually this is where you have to write formal test cases, execute the test case and raise bugs, etc. හරි මේ sequence diagram වගේ වෙයිලා object oriented වල තියෙන diagrams හරි මම ඔකට තමයි කිව්වා note එකක් දෙන්නම් කියලා මොකද ඔය exam එකේ මම දැක්ක පොඩි ගිය අවුරුද්දේ paper එකේ අහලා තියෙනවා පොඩි ඔයා නිකන් මේක දැකලා තියෙනවද කියලා check කරලා තියෙනවා හරි ඊට කියන්නේ use මේක මේ testing වලට අදාළ නැහැ මේක මේ sequence diagram එකක් හරි ඉතින් මේ test case එක derive කරන්න පුළුවන් නැත්නම් අපිට ලියන්න පුළුවන් මේ diagram එක දිහා බලාගෙන. මොකද product එක develop කරනකන් ඉන්න බෑ අපිට test case ලියන්න. product එක develop කරලා ඉන්න test case ලියලා ඉවර වෙන්න ඕනේ. So therefore by looking at use case diagrams, activity diagrams, sequence diagrams which were developed during the designing and analysis, the QA people can start writing their test cases. ඒකයි මේ කියන්නේ නැතුව මේවා දෙනවා කියන එක නෙමෙයි මේවා මේ විදිහ designers ලා ඇඳලා ඉවරයි. නැත්තම් analysis වලදී develop කරපු diagrams පාවිච්චි කරලා ඇඳපු diagrams පාවිච්චි කරලා QA team can start writing their test cases. Okay. Right. So test driven development is it's a new, I can't say it's a new concept, but it's relatively new concept where so the idea is the traditional approach or the traditional view was we develop the product, right? Develop, then test. But the new approach is first think about testing, then develop. So you may feel like it's very odd, right? How can you test without developing? So the test-driven development means before developing, you think about the testing. Sometimes you can write the test cases also, right? That is, of course, the QA people, not only QA people, your development team also has to think about the testing. I am going to test this in this and these scenarios. So once you think about the testing, if you have any ambiguities in the requirements, those things are resolved. And also you are going to see all the possible possibilities, possible use cases, then you are going to build it in a much more quality manner, right? And also you can start doing testing then and there, because you have thought about the testing before developing. And one of the concepts in test-driven programming is, especially in unit testing, you first write the unit test cases. Say, for this functionality, you have identified 20 unit test cases. You write those. That is why there are frameworks like JUnit, NUnit. Right? So there you call your unit methods and other things. Still, those methods are not executed, developed, but the methods structure or the stubs are there, right? So then, of course, your test cases are going to be failed because still these are not implemented. So then now you have first write your test cases. Of course, the test cases are failing because still you have not developed other than the skeletons. Now you start doing the development. So when you are proceeding with development, gradually these test cases are going to start making pass. Test fail na කියලා බය වෙන්න එපා. හරි test fail වෙනවා තමයි මුලදී. test driven development. හැබැයි ඔයා development කරගෙන යනකොට test case pass වෙන්න පටන් ගන්නවා. මොකද දැන් ඒවා develop වෙනවා ටික ටික. So that approach is called test driven development. So we are driven by testing. A lot of emphasis on testing. Okay. So the idea is we identify the issues as early as possible. So we identify the very first movement and fix it. Right? Fix it. So that is the idea. Okay. So we can start with test. අපි පටන් ගන්නේ testing වලින් develop කරන්න කලින් testing තමයි කරන්න පටන් ගන්න. සාමාන්‍ය එක හිතන්න බෑනේ නේද කොහොමද product එක test කරන්න කියලා නෑ මේ test case ටික ලියලා තියෙනවා අපි. ඒක fail තමයි. හැබැයි ටික ටික මේවා pass වෙන්න ගන්න. හරි. So tests are written before code. So that is very important. මේ slide එක කියවපය සමහරට ඔයගොල්ලන් අර experience එකෙන් මේක main concept එක ඔලුවට යනවද දන්නේ නැහැ. දැන් මම මේවට main concept එක තමයි කියන්නේ. Main concept එක තමයි tests are written before code. එහෙම කරනවා. එහෙම තමයි කරන්නේ නැත්නම් software development. So that is called test driven programming. Test වලින් තමයි drive කරන්නේ. Test කියන්නේ පස්සෙන් එන එකනේ නෙමෙයි. Test should pass and it is critical driver of development. හැබැයි ඒක අන්තිම නම් මුලදී pass වෙන්නේ නැහැ. You develop code incrementally along with test for that increment. හරි. for test develop වෙනවා code develop වෙනවා. නැතු code කරලා ඉවරලා test ලියනවා නෙමෙයි. Okay. You can see. So identify the functionality, write the test, run the test. If it is fail, implement the functionality and refactor. Of course, පළවෙනි පාර එක fail වෙනවා තමයි. පළවෙනි පාර fail නම් මොකද තාම ඉස්සර test එක විතරයි ලියුවේ. So if it is pass, now we are done. Otherwise, you have to implement and fix it again, blah blah blah. Okay. So these are some examples. Okay. මෙතන JUnit class එකක්. මෙතන ORG JUnit test. So this is a testing class. Okay, මේක test class එකක්. ඒක ඇතුලේ එයා මේ myUnit කියන unit එක develop කරලා තිනවා. ඒක යා method එක call කරනවා. 1 සහ 2 කියලා යවන්න ඕන. යවුවම යාට මොකක් result එකක් එනවා. ඒ එන result එක යා check කරනවා. අපිට මේ concatenate වෙලා එන්න ඕන. So this is මේ වගේ cute දෙයක් test කරන්න දෙයක් නැහැ. But assume when you are saying 1 and 2, what we are supposed to get is 1, 2. Now we are checking whether the result that we are getting is 1, 2. Asset equal කියන්නේ. මේ දෙක සමානවත් result එකට මේක ආවොත් test case එක pass කියලා build එකේ වැටෙනවා. දැන් තාම develop කරලා නැත්තම් මේ method එක අනිවාර්යයෙන් මෙහෙම 1 2 යවට පස්සේ 1 2 කියලා එන්නේ නැහැ. ඒක ඉස්සෙල් test fail. හැබැයි මේක develop කරනකොට develop වෙලා ඉවරනකොට ඔන්න ඔයාට 1 සහ 2 යවම 1 2 කියලා එන්න පටන් ගන්නවා. හරි මේක මේ චූට් කතන්දරයක්. හරි මේක develop කරන්න දෙයක් නැහැ. මේවට built in methods තියෙනවා. මේ පොඩි උදාහරණයක් කරන් තියෙන්නේ හරි. ඒ වගේ ලොකු කතන්දර තමයි වෙන්නේ ඊට පස්සේ හරි. උදාහරණයක් විදිහට මේ මාක්ස් ටික යවම ඉසෙට් ස්කෝර් එක එන්න ඕනේ මේක. අපි ඉසෙට් ස්කෝර් එක කැල්කියුලේට් කළා මේවා ටික යවලා අපි බලනවා මේ ඉසෙට් ස්කෝර් එක මේක එනවද කියලා. මේක එන්නේ නැත්නම් ටෙස්ට් ෆේල්. මේක ආවොත් ඔයාගේ ඉසෙට් ස්කෝර් කැල්කියුලේට් කරන ෆන්ක්ෂන් එක දැන් වැඩ. right? යුනිට් ටෙස්ට් එක පාස්. දැන් තමයි ඩෙවලොප් කරලා තියෙන්නේ මෙතඩ් එක. මේක ඩෙවලොප් කරනකම් නිකන් මෙතඩ් එකේ සිග්නේචර් විතරයි දෙන්න. මෙතන එක ලයින් නෙමෙයි ඇක්චුවල් සොෆ්ට්වෙයාර් එක ඩෙවලොප් කරද්දි මෙතන තියෙනවා සම ඒවයින් වෙන ඔබ්ජෙක්ට් කෝල් වෙලා හරි මේක දවස් ගානක ඩෙවලොප්මන්ට් එක සමානයි. හරි. right. So benefits of test driven programming. So as I told you, the earlier you find the bugs, better. Right? It will reduce cost and developers frustration and so many things. Okay. Right. So regression testing. And regression testing is testing the system to check that changes have not broken previously working code. හරි ඒ කියන්නේ මම ඔය ඉනකොට ටක්කල් උත්තරේ දුන්න එක අනිවාර්යයෙන් මේ ස්ලයිඩ් එක කියවලා ඉන්න කෙනෙක් නේ. right. අපේ අතින් මේ වෙන ෆන්ක්ෂනාලිටි කැඩලා නැද්ද කියලා තමයි මේ ටෙස්ට් කරන්නේ. හරි. ඒකට අපි කියනවා මොකද්ද regression testing. ඔකට අපි casually කියන්නේ software developers ලා smoke testing කියලා. හරි. නැත්නම් sanity testing කියලා කියනවා. sanity එක කියන්නේ health එක. regression testing. Okay. Release testing කියන්නේ ගොඩක් අය release එකක් දෙද්දී අපි කරන testing. හරි විශේෂයෙන් customer release එකක් දෙනවා නම් කරන testing. හරි. So that is a special case. So usually these are black box. හරි ඒවා අපි කරන high level එක. Performance testing I explained. And user testing means testing the sort of a final testing done by end users. සමහරවිට අපිට දෙන alpha releases, beta releases දෙන්නත් පුළුවන්. හරි. So that we can release to the customer and ask them to test it. Finally, of course, we have the user acceptance testing, but before that, we can even give alpha releases, beta releases, and ask end users to familiar with that, use it, and see how it goes, and are there any issues? Okay. Right. Alpha testing means the product is fairly stable, but still there are some issues. So therefore, still it is not beta. We say alpha stage. Right? So fairly stable, but not perfect, and there can be even some considerable issues. So therefore, it's not recommended to use or go production yet. Beta testing means now we change from alpha to beta when we feel like now the product is fairly stable. Still, it's not released, but it must be fairly stable. Actually, very little non-issues are there, and they are not very critical issues. Then we move from alpha testing to the beta testing. So then after sometimes during the beta testing, if they are not finding any issues, or if there are minor issues, if we can fix it, then we can go for the acceptance testing. That means officially we are releasing for testing, right? Acceptance testing. So if the acceptance testing is passed, of course the product is released. Okay, but it doesn't mean that always we do these two. Sometimes we don't do these two. We just straight away after system testing we go for acceptance testing. Okay. Right. Agile methods. In agile methods, remember we are giving releases in very quick sessions, right? Typically in every 3-4 weeks we give a release. So therefore, we are not going to do develop lot of functionalities in a particular iteration. So usually the product owner will give us the feedback. Right? Because it's one of the concept of agile development is at the end of the release or the scrum or sprint, we have to give a potentially shippable product increment. Potentially shippable means this has the potential to give it to the customer. Okay, so that means we have to have we must have done thorough testing before though it is every 4 weeks we are giving that that release. There's nothing called small release. The release is final product, right, with few more changes, few more features. It must be 100% tested, right? So, and your product owner will do the initial acceptance testing, and whether he will decide whether accept or reject that particular build. Okay, but they are very casually we do, because remember, product manager is also part of our team. So therefore it's a very casual process where we have a product review meeting, where the team members demonstrate the functionalities and the product owner will give us the feedback, and sometimes we can fix if there are minor issues. Okay, right, I explain you the black box testing versus white box testing. I don't know why they should have mentioned this at the beginning, right? Testing for right. Right, so we'll take a break, then we'll move on to the other topic, maintenance. Okay, so let's continue. Okay, so let's quickly go through this one also. Right, evolution. Right, so usually we don't use the word maintenance, right? All the other, right, mechanical engineering, electrical engineering, we say we have to maintain the vehicle, we have to maintain the power plant, we have to maintain the ship, right? We have to maintain the building. But in software, we call it evolution. The main reason is, unlike mechanical or electrical engine, once you build the power plant, you don't do much change unless you build another power plant or phase 2 or another turbine. But when it comes software, we keep changing, because two reasons. One is we develop software mainly for businesses. So businesses are very dynamic, right? Very dynamic, highly competitive. So therefore we have to keep improving, keep providing more features, but the customers need, we have to keep increasing customer satisfaction. That is the reason number one. Reason number two is, of course, software is a soft thing. So soft things we can easily change, unlike a hard thing, like a ship or power plant. So therefore, we can change it easily, and also since it is for business purposes, we have to change it. That is why we call it evolution. But maintenance is part of it. Okay, right. So let me quickly explain few things, then I will go through the slides. So when it comes to evolution, these are the tasks we have to do. Evolution. Of course, we have to do some changes, modifications, right? Then we have to do some bug fixes, issues. If there are issues, we have to fix. And then we have to do day-to-day change maintenance, like user management, security, monitoring, backup and recovery. Right? So that is maintenance stuff, right? Day-to-day maintenance, right? And also we have to do some evaluations. Periodically we have to evaluate whether the product meets the current requirements. So do we have to do some big changes, or do we have to go for a new system? Is it time for the new system? Right? So we have to think, right? Changes, bug fixes, improvements, day-to-day maintenance, evaluations. So those are part of the evolution. Okay, and there are challenges in the evolution stage. The biggest challenge is, now the team members are no longer there. Maybe we had 20 software developers. We can't retain all 20 software developers, because evolution stage you don't get a lot of tasks, right? And also software developers don't like to retain in an evolution stage project because they don't have much work to do, right? So they don't have any challenging work to do in the evolution stage. So therefore, maybe just one or two software developers or some new software developers or part-time people will be there. So therefore, so those who changes made by other software developers, now these software developers has to take care of some changes, bug fixes, etc. The second challenge is when the software is keep modified. Say now we developed it 2 years back, and during the last 2 years also we have been doing some changes. Of course, improvements, but whenever you do some changes, some of those changes may not have been anticipated. So in general, the structure of the software get deteriorate. The more you changes, unanticipated changes, more unstable the code base is, the design and other things. So therefore, we have to work with deteriorating code base, and also those technology and other things will be outdated. Maybe during that development time we were using Bootstrap 4. Now Bootstrap 5. Unless you have upgrade to Bootstrap 5, and now you have to work with that old code base. So likewise, there are so many challenges are there, right? When it comes to evolution, which we have to overcome. Okay. Right. So let's quickly go through your slides. Right. Software changes here are inevitable. So I told you, inevitable, right? It's a normal thing because of high competition, business challenges, etc. Okay. And also the software field is highly evolving, right? Highly changing, new versions, right? New JDK, new operating systems, new database versions, new framework versions are coming. We have to keep up with the new things. New technologies comes. Okay. So unless you keep up with those things, your software is going to be outdated pretty soon. So then you have to go for a new project, new product. Okay. So it's sort of a spiral or cyclic thing. Okay. So you can now read these things. Okay. So there are some changes coming. So then you have to do some proper change management. So when a new change comes, what you're supposed to do is first update your documents, your requirement documents, design documents, etc. Then apply the change. So then your system and the documents are compatible. Otherwise, some people, they just apply the change, then your documentation and system is not compatible. Okay, so we have to update our design documents, etc. Because maybe in 3 months time, another set of new developers are doing the maintenance. So then they are relying on the documentation. Okay, and also when there's a change, we have to evaluate and see what is the impact, what is the cost. Is it really worth? Then only we accept the change request and do it. Or sometimes we can even reject the change request saying that it is too risky or too much of effort and blah, 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 too costly. So when we get a new change request, we have to analyze the source code and check, are there any risk involved? Is it feasible? So then only you do the modification and deliver. Okay. Right. So legacy systems means basically outdated systems. The systems that we have used for some times, and now those technologies or maybe functionalities and things are outdated. So then we say we have a legacy system. So we try to replace legacy systems as quickly as possible. But sometimes we have to, due to financial constraints, etc., we have to use these legacy systems for longer time as well. Okay. Right? You can read these things. These are easy things. Okay. And doing changes to legacy systems is even harder because sometimes we don't have developers who are capable of doing that because those are outdated technologies now. Okay. And sometimes we find it extremely difficult to integrate those systems with the other new systems. Right? So many complications are there. Right? So ultimately, remember I told you that we have to do some reviews time to time, and maybe later we will decide that, okay, now we are going to discontinue the legacy system. We are going to develop a new system, or we are going to get a new system replacing the legacy system. Okay. So these things you can read. Okay. Right. So the maintenance involve user management, backup and recovery, monitoring for the possible attacks, etc. Okay. So those are part of the maintenance. And of course, they have taken even some bug fixes also as maintenance, adding new modifications, changes. ඒවත් ඒගොල්ලෝ maintenance කරා. ඒවා ඇත්තට maintenance වලට වඩා evolution වලටයි ආයි. Yeah. So we have to predict the possible maintenance, possible changes. So that is why we need a maintainable, reusable coding, right? Like object-oriented concepts like polymorphism, inheritance. So if you do a proper designing, those modifications are going to be much more easier and less risky. Right? Sometimes we do something called software re-engineering, where we come up with, it's related to business process re-engineering as well. We come up with big changes to the existing systems, right? Using new technologies rather than building a new product, new software product. We can do big changes to the existing systems and make it again sort of a modern system. Okay. So that is called re-engineering. Okay. So it reduces the risk because we are not developing a new system. Right? Already functioning things, we are doing some big changes. And also it reduces cost because we are not developing everything. So we're just doing some changes to that. But there are limitations. Sometimes when your product is very old, re-engineering is not possible. So then we have to go into a new product rather than doing re-engineering. Okay. So refactoring and re-engineering are a bit of two things. Refactoring, but re-engineering is doing considerable or radical refactoring. Like usual refactoring means doing small minor changes. Okay. Right. So bad smells program code means, now I told you that when your program is getting age due to so many changes, etc., and those changes are done by various people, your code get deteriorated. So its quality is getting less and less and less stable as well. And now the coding conventions and those things may have been violated because not the original developers are doing those changes. So there can be duplicate code, long methods, right? Data clumping, speculative generative, what happened? Bad smells. Quality එක අඩුයි කියලා මේන්ටේන් කරන්න අමාරුයි කියලා අපිට ටික ටික තේරෙනවා කෝඩ් එක දිහා පාවිච්චි කරනකොට සහ මොඩිෆිකේෂන් කරන්න ගත්තා. Right, so that's it. You have to read it. I didn't go into detail. Right, so now we'll be doing the 2020 past paper. Okay, past papers වලට BL එකෙන් ගන්න පුළුවන් නේද? you should be able to get it from the VLE. VLE past papers tuna. Right. So this is 2000. This is the only semester 2 software engineering past paper, but you can do semester 3 past papers MCQs. Okay, exact sort of exact syllabus. Therefore, no issue, right? But the Paranagati Vitra the semester 3 past papers part BLE ke pay නැත්නම් මම දාන්න. අපේ එකේ තියුණක් දන්නේ නැහැ නැත්නම් මගෙන් ඉල්ල ගන්න මම දෙන්නම්. ඒකේ තවරු 3කවත් කරගෙන යන්න. ඒවා ඉතින් ප්‍රශ්න 20ක් 25ක් තියෙන්නේ. මොකද level 2 වල papers දෙකක් දුන්නා හන්දා. Anyway, let's first do this one, okay? Right. So this is the only level 1 software engineering past paper, right? But you have level 2 past papers, do their MCQs, okay? Not the essays, structured essays. Let me open the answer sheet also. Paper past paper එකක් කරාට පස්සේ මට තේරෙන්නේ මොනවද අහන්නේ මොනවද අහන්නේ නැත්තේ නේද? වැඩියෙන් ફોකස් කරන්න ඕන මොන වගේ areas වලටද? Right. Question 1. බලන්න මේ MCQ වල answers එකයිද හරි ඒවා බලන්න ඕන. හැම paper එකකින් paper එකට බලන්න ඕන. නැත්තම් each question will have 5 choices with one or more correct answers. That means multiple answers are possible. Right? Semester 2 වලත් ගියාම හැම paper එකකින් paper එකට check කරලා තමයි උත්තර ලියන්නේ. One or more ද නැත්තම් only one ද? Right. Question 1. Which of the following are not application software? So that must be an easy question. We remember we can subdivide it into system software, application software. System software involve operating system, program translators, and other system utilities like disk defragmenters, security, network monitoring, etc. Not application software. That means system software. Graphic software, they are application. System utilities, they are not application software. Word processing, application software. Security monitors, they are sort of a system utilities, right? Accounting software application. මේවා debatable වෙන්නත් පුළුවන් exam සමානලට එහාට මෙහාට කරලා වෙන විදිහට හිතන්නම පුළුවන්. ඒක ඉතින් part of ඒකත් එක්ක අපිට we have to live with. So I will take not application software so may I will application software තමයි mark කරේ නේද? Graphic software, word processing software, accounting software. So application software නොවෙන්නේ මේ දෙකනේ B සහ D. B and D. Let's see the answers. Yes, B and D, correct. Okay, that is easy question. Which of the following are true with respect to software projects? So other thing is now Wednesday. No, you have the classes Thursday, right? So Thursday we are going to do another maths paper. No, another database paper. So if we did 2020, I think we did 2 papers, right? No, we are going to do a maths paper. බලන්න අන්තිමට මම කරන paper එකේ මේක දාන්නම්. ඔයගොල්ලෝ ඒවා කරලා තියෙන්න ඕනේ බయ్యා. ඉදාට. And also we can do another class on Friday. Friday අපිට කරන්න පුළුවන් class එක. මොකද Friday semester 6 එකේ exams ඉනන් දෙකකට class නැහැ. Then we can do another class on Saturday also. ඒකට සෑහෙන වැඩි ඉවර කරගන්නයි මම මේ බලන්නේ. මොකද ඊළඟට ඔයගොල්ලන්ගේ exams එකක් නම් ඊළඟ සතියේ නේද? ඒකට ඊළඟ සතිය කරන්න නැතුව පුළුවන් තරම් මේ ටිකේ. So we have Thursday, Friday and Saturday. හරි ඒ වුණොත් තව ඕන එකක් දාන්න පුළුවන් ඒක Tuesday ට. හරි මොකද අපිට වෙබ් වල තව පොඩි topic එකක් කරලා past paper එකක් කරන්නත් තියෙනවා. හරි right. Question 2. Which of the following are, and also if you have any specific questions just post it to the WhatsApp group or whatever. මම සමහරට මට attention ගියේ නැත්නම් ආයෙ කියන්න. මම පරණ videos ටික upload කරා. විශේෂයෙන්ම mean අපි කලින් දවසේ කරානේ mean stack එක භාගයක් විතර කරලා තියෙන දැන් ඒක ආයි බලා ගන්න practically code උත් එක්ක හරි මොකද ගොඩක් ප්‍රශ්න අහලා තියෙනවා. Right. Which of the following are true with respect to software projects? The environment to which software is made do not change regularly. That is wrong, right? The environment frequently change. Business environment. Small change to a few lines of code could do a big change to the overall behavior of the system. So that depends actually. So it depends on the type of change. Like sometimes yes, sometimes no. So those are debatable answers. Okay. Because of intangibility, intangibility means conceptual nature, it's not physical. It is difficult to specify software. Yes, right. When something is not physical, the specification is difficult because it's a conceptual thing. Yes. It is difficult for a customer to specify requirements completely. Yes, right. So because requirements are also conceptual. So therefore there can be some ambiguities, etc. ගෙදරක් නම් අපිට හරියට කියන්න පුළුවන් මේක මෙච්චර මෙච්චර පළ මෙච්චර දුස වෙන්න ඕනේ මෙච්චර පළල වෙන්න ඕනේ නේද? හැබැයි software එකේ එහෙම බෑ මේක concept එකක්. It is easy to test software exhaustively. No. Exhaustively means completely. So software is a conceptual thing. A lot of concept complications are there. It's extremely difficult to test unless it's a hello world application. Okay. Right. Hello world වලින් එහා ලෝකයක් තියෙනවා. Right. So what true අහන්නේ I will go for C and D. Small change to few lines. ඉතින් මේක software වල එහෙම ගතියකුත් තියෙනවා හැබැයි මම මේ ගන්නම් sure නෑ මට. මොකද ඒක debatable answer එකක්. But I will go for C. Okay, I will go for all three, but B can be debatable answer. Okay, second one, let's see. Right. So examiner has taken BCD. Yeah, B around BCD. Third one. Which of the following is are not true with respect to software cost and failures? Right. Software cost and failures. Right. Increase in the system complexity is one of the main reasons for software failures. Yes, right. So when the system is getting more and more complicated, there's a higher chance of failure, right? Increase in the system complexity is one of the main reasons for software failure. So we can take it as a correct one, right? Software development cost decreases rapidly over the time. Is that the case? No, right? So the software development cost is getting increased because people's, it is all about their salary. So usually the people's salary goes up. The hardware cost is getting down. The software cost is getting up. Okay, so there is a normal scenario. Anyway, let's see how the examiner look at it. Right. So this says software development cost decreases. Sorry, that means it's wrong, right? Software does not wear out in the same sense as hardware. Yes, there's no wearing. There's no wearing, right? Software කොච්චර පාවිච්චි කරත් ගෙවෙන්නේ නැහැනේ. Failure rate of software can rise when new changes is introduced to the software. Yes. Right? So whenever new change is introduced, there is a possibility of new failures also because the modifications may have introduced new bugs. Yes. Change එකක් වුණා කියන්නේ ආයේ failure rate එක වැඩි වෙනවා. Use of software engineering methods minimize software failures. Yes. So when you use proper software engineering methods like proper testing, proper designing, right? So it minimizes the software failures, right? Discipline. Right. So the question is not true. So we can take B as not true, right? This is software does not wear. Yeah, that is correct. Others are correct, right? Yes, we'll take B. Okay, third one B. Yes, only B. Fourth one. Which of the following is are not a key challenge facing software engineering? Heterogeneity. It's a challenge, right? We discussed that. Heterogeneity means software engineers need multitude of skills, right? technical skills, business skills, conceptual skills, problem solving skills, critical thinking skills, logical thinking skills. And when it comes to technology, the database, right? UI development, integration, so many analysis, design, heterogeneity is a key challenge. Increasing the power of hardware. That is not a challenge for the software engineering, right? So when the power of hardware is getting increased, that is good for us. It is not a challenge, right? I don't take that. Security and trust. Yes, it's a challenge. Right? It's a challenge. Right? Trust challenge. Heterogeneity, trust, those are the challenges. Rapid growth of the social media. I don't know whether it's a challenge or not, right? Of course, we have to develop software to cater for those people as well, but rapid growth of social media, I don't think, in a way, it's a challenge because we have to integrate with social media, etc. In a way, it is not directly related to us also. So that is a debatable answer. Business and social changes. Yes, it's a challenge, right? So when business change, society change, so we have to adapt. But these things can be debatable. Okay. පොතේ විදියට නම් බොහෝ විට අපි ගන්න A සහ C. ඔය දෙක නම් හොඳටම මට මතකයි මෙන්ෂන් කරලා තුන ස්පෙસિෆිකලි heterogeneity සහ security and trust කියන දෙක. හරි. So therefore, yes, anyway, I will go for A, C, and E, but I'm pretty sure about A and C. Okay. Not A1, not key challenges. B and D. Maybe examiner might consider E also, but I will go for B and D. 4. Yes, B and D only. So examiner has not taken business and social challenges. They are challenging. Right. 5. Which of the following these are not an activity or activities of typical software process? Aggregation, activity. Validation. So validation is pretty much the testing, right? We can take it as a testing. Evolution, obviously. Implementation, obviously. Abstraction is not a software development activity, it is an object-oriented concept, right? Aggregation is also concept in the relationship between classes. So we'll take not ahanne, not na A, E, because these are some stages or activities, right? A and E. A and E. 6. Which of the following is are not true with regard to waterfall model? Those are easy questions, right? So remember, we have two types of software development: the traditional waterfall approach or sequential approach, then the iterative approach, and then special case of iterative approach called agile approach. Right. So this is waterfall, sequential, long delay before delivery, right? So we do one task at a time, and its documentation has a lot of emphasis, and it's not very friendly to the modern dynamic competitive environment. It is for very traditional, right, environment, right? It is good example of plan driven process. Obviously, yes, there are two approaches: plan driven, agile. So plan driven means we have a proper hard plan and we are committed to the plan. Agile means we have only tentative plan, high level plan, and we are very flexible. We adapt to the situation. So plan driven is this one. And this one also bit off, but agile is completely opposite. We do not overcommit to plans. We can't do like that in modern, dynamic, competitive environment. It's very dynamic. We have to adapt and flexible. Okay. It is a good example of plan-driven process. Yes. Right? What we need is not true. It is more suitable for projects that have vague requirements. Right? So when we have vague requirements, can we finish requirement analysis and go to the design? No, right? We have to, while we are developing, we have to gather those things, right? I don't know. It's both ways we can argue, but usually when the requirements are vague or ambiguous, how can we upfront finish requirement analysis? So therefore, I will say no. Again, this can be a debatable answer. So far, my answers and examiner's answers were pretty much tallying, but let's see. Usually, when the requirements are vague, it's difficult to finish it, freeze it, and then say designing, right? Because it's vague. Okay, so therefore, I will say no, not true. It allows clients to provide their feedback during system development. No way, because we at the end only we are giving the product. The feedback can be taken when we have iterative and agile. So this is wrong. It plans and schedule all the process activities before starting software development. Yes. So that is why what is known as a plan driven. Okay. It is an old method that is not popular now. Yes, it is old method that is not popular now. So I will go for B and C. B and C. B, C, and they have taken E. Okay. So examiner says that this is wrong. Examiner says that it is not a old method, and examiner thinks that it is very popular now. I don't agree at that as at all. I don't agree with that at all. But anyway, there can be disagreements. This is degree level. Okay. So your examiner thinks that the waterfall method is not a old method, and waterfall method is very popular right now. So that is why not true. So I don't agree with that at all. For me, waterfall is the old approach. Waterfall is not right now popular. Very rarely people use waterfall. Okay, in business of in the industry. Okay, right. Anyway, it's a disagreement. Right, 7. It says. Sorry. It says not true, right? So when we say not true, this is not true. Right, correct. But old method is correct. So that again, there's a all this part is correct. Right, old method. But yes, not popular is also correct. Right now it is not popular. So both are correct. What they ask is not true, but this is correct. Old method is correct. Not popular now is also correct. Right? It is old method and it is not popular. What they ask is not true, but this is true. So therefore, E can't be answered. That is my argument. E cannot be answered because this is correct. It is old method and it is not popular. But your examiner says it is wrong. Right? It is wrong. So that is my concern. Okay. Right. 7. Which of the following is are true with regard to incremental development? Incremental development means another name for iterative development. At the end of each iteration, more features have been added. Okay. Right. The process is not visible. I don't know what is meant by not visible. Errors are difficult to identify. Okay. The software could be developed faster during the software life cycle. All are debatable answers. System structure tends to degrade as new increments are added. That can happen because maybe some of the changes that you are going to do absorb because new requirements are absorbed. You may not have anticipated at the beginning. So then the software structure or the architecture or the design can degrade fast as well. That is one of the disadvantage of agile as well, because we are not upfront think about the entire requirements and do a design. So therefore, our design may not scale up. The design may not fit to some requirements that may come to the surface later. Okay, software could be developed. Okay, system structure tends to degrade as new increments are added. Maybe that is correct. It is not flexible and so expensive if requirements and scope changes. No, right? If the changes, this is where we can easily absorb changes. And it is flexible because we do it in iterations. So we'll say no. Right. So what they ask is true. The process is not visible. I think when it is incremental, I don't know what is exactly the examiner means. Maybe visibility means the visibility between customer and the development team. Right? We get feedback, customer get early releases. I will say it is visible. I'm not very sure what is mean by visible or what the examiner mean by visible. But visible, if visible means the communication or the feedback, of course, this is visible than traditional approach. Okay. So therefore, I will say no because it says is not visible. Okay. Errors are difficult to be identified. I don't think so, right? Because we quickly do testing and give releases. Customer can give, if there are errors, customer can very early give us the feedback. Right? Difficult to, I will say no. The software could be developed faster during software life cycle. I think that is correct, right? Because when it is come to incremental, it push us to do fast as well because we have quick releases. When it is waterfall, we tend to waste our time doing a lot of analysis, design, because no release in the ළඟපාතක release යන්නේ release එක තියෙන අපන අවුරුද්දේ. හරියට ඔයගොල්ලෝ A level කරා වගේ. A level කරනකොට A level විභාගෙ තියෙන අවුරුදු දෙකකට පස්සේ ගොඩක් අය A level කරන්න අර අන්තිම පළවෙනි අවුරුද්දේ මෙලෝදියක් නොකර ඉන්නවා සමහරව. ඇයි? තව අවුරුදු දෙකකින් විභාගෙ තියෙන්නේ කියලා. හැබැයි ඕක මාස අවුරුද්දෙන් අවුරුද්දට අනිත් රටවල අවුරුද්දෙන් අවුරුද්දට A level තියන්නේ නේද? A level AS1 AS2 දැන් ඔයගොල්ලන්ගේ semesters විද්ද කඩලා තියෙන්නේ. So that means වැඩේ වෙනවා දැන්. නැත්තම් ඔහෙ ඉන්නවා පළවෙනි මාස 6. ඔයගොල්ලන්ගේ එකපාරට exams ඉපි කොරෝනා නම් නැත්තම් මාස 6න් හැට තියෙනවා. Right, the software could be developed faster. I will say yes. So then 2A වහන්නේ I will go for C and D. 7. C, D, they have taken A also. ඒ කියන්නේ not visible කියන එක true. Process එක visible නෑ. I don't know. Maybe the examiner has considered as what he has considered as visible is maybe we are now not doing, we have lack of planning now. Maybe in the waterfall approach there is a big plan and we are doing according to the plan. But when it comes to iterative or incremental, it's sort of a adaptively we have to do. Maybe that might be the reason, right? මෙතන visibility කියලා එයා එක ගන්නක් ගත්තා වෙන්න ඕනේ නැත්නම් customer අපේ අතර තියෙන visibility ගන්න වැඩි, right? So maybe that might be the reason why examiner take this as a correct one, not visible කියන එක අරන් ඒක වෙන්නේ, right? Right. 8. Which of the following is are not process stages of reuse based software development? ඒක නම් වගේ slide එකේ ඇති හරියට මට හරියට මතක නෑ. හරි. ඔයාගේ slide එකේ හරියටම ඇති reuse based software development වල තියෙන stages මේක කියලා. මම මතකෙන් අපි කරමු ටක් ගාලා ඉස්සෙල්ලා. Component analysis වගේ එකක් නම් තියුණා මට මතකයි. Requirement specification I think we need. හැබැයි ඔය වගේ question වල examiner බලන්න හරියටම වචන තියෙනවද කියලා තමයි බලන්නේ. Software discovery and evaluation, requirement design. I don't think there's something called requirement design. ඒ දෙක ගැලපෙන්නේ නැහැනේ. Application system configuration, component adaptation and integration. I think we have to do this. We have to adapt some components and integrate because we are going to use a lot of existing components. Okay. maybe software discovery and evaluation, requirement specification, application system configuration. What is that? Not the okay. I'm not very sure about that. I will go for C and D. මතකෙන් විතරයි ගන්න බෑ. ඔබ වගේ note එක අනිවාර්යෙන් දිනුනා හරි. බලමු උත්තරේ. 8. They have taken only C. ඒ කියන්නේ D තරම් තියෙනවා. So that means application system configuration is also there. I think we have to configure those modules together, right? Yes, they have taken that also. So that means මේ කොහොමද බැල බැලම තේරෙනවා මේක බොරුවක් කියන්නේ නේද? requirement design කියන්නේ නැහැ. requirement කියන්නේ requirement, design කියන්නේ design. හරි? So එහෙම බැලුවොත් ඒක හරි. නමුත් මම හිතුවා මේකත් වෙන්නේ නැති කියලා. නමුත් ඒක අරගෙන නැහැ. හරි? But anyway, these things were there under system analysis topic. Okay. 9. Which of the following these are not a process improvement activity? Right. Process improvement means we have to improve the process. We don't want to do the same things in the same way. If there's a better ways of doing things, that is why in agile development, at the end of every cycle, every sprint, sorry, not sprint, every end of each sprint, we have 2 meetings. One is the sprint review, where the product owner gives the feedback. Other one is a sprint retrospective meeting, where team members discuss how to improve the process, what went really well, what went wrong, what are mistakes we made, and so that we don't want to make that mistake again. Right. Which of the following these are not a process improvement activity? Process measurement. Question. Maybe we have to measure, right? Measure, process measurement, process analysis, process validation, process evolution, process change. I have no idea about that. එකත් බලන්න කොයි හරි වගේ note එකේ සිවුනද කියලා හැබැයි මට නම් ෂුවර් නෑ. හරි. what are the answers? එයා කියන්නේ not ඒවට C සහ E. process validation සහ process evolution කියලා එකක් නෑලු. අනිත් ඒවා හරියි. process analysis, process measurement, process change. පොඩ්ඩක් බලන්න slide එකක ඇති ඔක. Right. 10. Which of the following these are not agile software development methods? Right. Agile development methods no වෙන්නේ මොනවාද? Agile development methods තමයි මොනවාද? Scrum, XP තමයි ප්‍රධාන දෙන්න. ඊළඟට Kanban වගේ. Right. XP, Scrum, those are the 2 main. Then the Kanban, Lean, over the agile. So spiral is not agile. Prototyping is not agile. Eva ita karinti vicha. Apeng are not eva. A and D. Right. A and D. A and D. Which of the following these are not an agile principle? මම agile ලෝකන්ට වෙනම කරාද? කරේ නැත්තම් මට පුළුවන් semester 3 එකේ agile ඒගොල්ලන් subject එකක් තියෙන එකේ පළවෙනි session එකේ වීඩියෝ එක දෙන්න. ඒකේ agile ගැන overview එකක් කරනවා. හරි. Let me check. agile topic එකක් විදිහට තියුන්නේ නැහැ නේද? වෙනම. කරානේ. කරා. වැඩි කරා. හරි. වැඩි කරා. agile level වෙනම topic එකක් විදිහට කරා. මම revision එකේදී හැබැයි agile කතා කරේ නැහැ. හරි. agile කතා කරේ නැහැ. පොඩ්ඩක් අපි agile කතා කරමු චුට්ටක්. Because examiner can ask a lot of questions on agile. Right. So in agile development, now remember we have the plan-based development or the sequential plan-based development. That is waterfall. And then we have the iterative or incremental. The prototyping, RUP, rational unified process, rapid software development, right? Iterative. So then came the agile development. So this is a big difference because here we do as a sequence and give a release at the end. But here now we have the iterations. We have iterations. At every iteration we can get feedback as well. Right? And we can absorb new changes, etc. So then agile is just a same concept, again iterative, but the approach is more flexible, right? So therefore it's not a big change from here to here. Only thing is now we have the agile philosophy. Agile philosophy. It's philosophical change. Simplicity, leanness, lightweight. Okay. What else? Customer orientation, customer participation. So those are some agile concepts we use. Okay. Lot of emphasis on the end product rather than documentation. Lot of emphasis on collaboration and high band communication. So those are, and remember we have the agile manifesto and agile principles, 12 principles and 4 agile manifesto points. Okay. And we can look at the agile development in 2 ways. So there are 2 main concepts, agile philosophy and the agile methods. So philosophy is the leanness, simplicity, right? Customer focus, those things. Okay. The methodology are Scrum-based development, extreme programming, Kanban, and we can take even lean development. Scrum-based development and extreme programming. Okay. So remember when it comes to agile, there are on 3 roles. What are the roles? Product owner, Scrum master, the rest development team. So then there are some activities. Right? What are the activities? Product grooming, sprint planning meeting. And it was a daily sprint or daily Scrum meeting or stand-up meeting. At the end of the Scrum, we have the product review and the retrospective meeting. So then we have the artifacts. So we have user stories. Those user stories will be initially in the product backlog. And when we are starting a new sprint, we have the sprint backlog. Product backlog is dynamic, sprint backlog is not dynamic. So then you have the burn down chart, burn up chart, burn down chart, burn up chart, Kanban board, to-do list, work in progress, done. Then of course the potentially shippable product increment is also artifact. What are the tasks of product owner? Right? He has the product vision. He owns the requirements. He is the go-to person for clarification on requirements. He is the one who is going to feedback on the releases. Ideally, he must be from the customer side. Then the Scrum Master. He is a servant leader. He is a coach. Right? And also, he provide the help team members to follow the agile concepts. Right? So he is not a manager. He's someone who is going to help us rather than managing us. Okay. From master, very talented, experienced, skilled, respect, who can earn the respect of the team member, other team members. So he's a senior person, talented person, who can inspire others, not who can manage others. Managers like makalakan. දැන් මේ රට මැනේජ් කරනවා නේද? දැන් දැන් පුළුවන් ද ගෝඨාභයට පුළුවන් ද මේ රටේ මිනිස්සුන් ඉන්ස්පයර් කරන්න? සජිත් ප්‍රේමදාසට පුළුවන් ද ඉන්ස්පයර් කරන්න? සිරිසේනට පුළුවන් ද ඉන්ස්පයර් කරන්න? අනුර කුමාර දිසානායකට පුළුවන් ද ඉන්ස්පයර් කරන්න? බුලත් කඩයක්වත් කරලා තියෙනවා අනුර කුමාර දිසානායක. රටක් ඉන්ස්පයර් කරා. බයිලා ගහනවා මිසක්. ඉන්ස්පයර් කරන්න පුළුවන් කට්ටිය වෙනම ඉන්නවා. ආයතන ගොඩනගන කට්ටිය, ව්‍යාපාර ගොඩනගන කට්ටිය. So similarly, therefore, the Scrum Master is a experienced, talented, respectable software engineer. Right? So then others respect them because you have done. දැන් මහේර ජයවර්ධනට ඇවිල්ලා පුළුවන් ටීම් මෙම්බර්ස් වලට බැලලා යන්න. මෙහෙම කරන්න, මෙහෙමයි කරන්න ඕන. අපි ගහපු විදිහට ගහපල්ලා කියලා. හැබැයි එහෙම ඇවිල්ලා කියලා යන්න බෑනේ අසන්ත දෙමෙලට. නේද? එහෙම කියලා යන්න බෑනේ මේ ඔය නිකන් මැච් එකක් දෙකක් ගහපු එකකට ඇවිල්ලා නේද? So that is the difference between a Scrum Master and a project manager. Right? So then the rest of the team members are there. And then කරගෙන යයි codes ටික questions ටික, because in the revision I forget to mention about those things. Right, so next question. Which of the following these are not an agile principle? Right, එකන එකක්ද? and ඉසු තියෙනවනේ එකක් වෙනත් පුළුවන් ගොඩක් වෙනවා. Highest priority is to satisfy the customer through early and continuous delivery of valuable software. That is correct, right? Customer focus, right? It is not we develop what we like, what we are good at. No, we develop what the customer really need. Right? So that is correct, right? Welcome change in requirements even late in the development. So that is one of the agile මේ මොකේද philosophy වල තියෙනව නේද මේක කරා. Yes, we accept changes even at the late. Deliver working software at the end of the project. Is it at the end of the project or continuously? Deliver working software at the end of the project. I don't take that. So we frequently deliver, not at the end of the project. Every 4 weeks, every 5 weeks, we deliver working software. So I will not take C. Business people and developers work separately. No, business people and developers work as a team. Wrong. Working software is the primary measure, of course, not the documents and other bullshit. It is the software. Right? So not අහලා තියෙන්නේ, so therefore we'll go for C and D. Okay, 11. C and D. 12. 3 pillars of the Scrum are. ඒක නාගේ note එකේ තිබුණා මට හරියට මතක නැහැ මොනවද 3 pillars කියන්නේ කියලා. කියවනකොට මතක් වෙයිද බලමු. Transparency, verification, inspection, adaptation, agility. So මට මතක විදියට ප්‍රධානම concepts තමයි philosophy එක පැත්තේ transparency, adaptation, inspection. ඔක්කොම එක වගේ අර නේද? ඔක්කොම නිඹුළු තුන් දෙනෙක්ව පස් දෙනෙක්ව තියලා තුන් දෙනෙක්ව යන්නේ කොහොමද? Verification, agility, inspection. Okay, මට හරියට මොනවද මතක නැහැ. ඔක note එකේ තියුණා. හරි. මොකද මේක I will go for A, D and E. Okay, but I may be wrong, okay, because I can't remember exactly. ඔක්කොම වැදගත් ඇත්තටම හරි. Right. Let's see the answer. So they have taken A, C, and D. A, C, D. ඒ කියන්නේ මේක වගේ වරද්දලා තිනවා. A, D දෙක හරි C අරන් තිනවා E වෙනුවට. So agility කියන එක වෙනම අරගෙන නෑ මොකද agile නේ නම නේද? So අනිත් පැත්තෙන් අරන් තියෙන්නේ මොකද්ද? Inspection. Transparency. So we are very transparent, especially within the team members. ඒක තමයි අර හොඳට පේන්න හැමතිස්සෙම ගහලා තියෙන burn down chart එක, Kanban board එක. So everyone knows. ඒවා project manager එකේ තියෙන රහස් දේවල් නෙමෙයි. Right? Customer and development team regularly meet. Okay. Adaptation. We adapt to the situation and we change. That is why we have the retrospective meeting. We even change the process at the end of each iteration we modify the process, right? Inspection means basically we inspect karna කියනවාද requirements වගේ අපි evaluate කරනවා, inspect කරනවා, refine කරනවා නේ. So I think the answer is correct, right? A, D and C. මොකද මේක agility කව මේක කෙලින්ම ආයි පිළ එකක් වෙන දෙයක් නෑ නේද? නමයි agile තියෙනවා. Yes, so the answer should have been A, D and C. 13. Which of the following is are not true with regard to requirements? Not true. Requirements contains the descriptions of the services that a system should provide and the constraints on its operation. So that is correct, right? So what the system should provide are the functional requirements. Constraints on its operations are the non-functional requirements. So the functional and non-functional requirements are the requirements. Correct. It is easy for client to express their requirements. No, they find it difficult because it's intangible and lot of ambiguities. Designing the requirement using engineering approach is called requirement engineering. I don't know what is this designing the requirements. Usually requirements you can't design. You design product. Right? Requirement design can, right? So we'll say no. A structured document setting out detailed description of the system functions, services and operational constraints is called system requirements, or we can call it system requirements specification, SRS. Right? SRS කියලා අපි ඔකට කියන්නේ නේද? So it has the systems, functions, services, operational constraints. So that is non-functional requirements. We say yes. The term requirement is not used consistently in the software industry. The term requirement is not used consistently in the software industry. I don't think so. But anyway, it can be a debatable answer. So requirement is a very defined thing, right? The functionality is expected. But yes, there are ambiguities, right? Functional requirements, non-functional requirements. But I think we can agree, everyone can agree what is a requirement is, right? So I will say no. Then I will go for B, C, and E. So E is the debatable guy. Okay. B, C, and E I am going. 13. Yes, pena. Debatable lekena aranne. Right. So one key ekay මෙයා තමයි debatable lekena කියලා. E වරගෙන නැහැ examiner. Examiner කියනවා එතකොට මොකද්ද මේක හරිද? The term requirement is not used consistently in the software industry. මම මේක ඒ පැත්තට දාන්න පුළුවන් කියලා නේද? ඔය requirement කිව්වම එක්කෙනෙක්ට requirement එක කියවෙන එකක් තව කෙනෙක්ට requirement එක නොවෙන්න පුළුවන් එක්කෙනෙක් නේද? ඊළඟ මේක functionalities, non-functionalities පොඩි කතන්දර තියෙනවා. I think agree වෙන්නත් පුළුවන්, agree වෙන්න බැරි ෆසිතනුත් තියෙනවා. So it can go here and there, right? So the examiner has taken this as a correct one. So the term requirement is not used consistently. That means different people use the word requirement for slightly different meanings. Okay. 14. Which of the following would be the functional requirements of a system which allows online shopping for customers? Typical requirements then බලන්න ඕන. The system should be fast enough to work without delay in the business process. So that is performance. Performance is non-functional requirement. Regular customers shall be able to log into the system. So login is a functionality, right? Yes. User interfaces of the system should be easy for customers to operate without any confusion. That is user friendliness, non-functional requirement. System should provide the total value of shopping cart at time of checkout. That is a functionality, expected functionality. System should be available 24/7 for all customers. So that is reliability and stuff like that. That is non-functional requirement. Okay. So what they need is functional requirement. The answer must be definitely B and D, right? B and D. So I'm doing this question with you for the first time. I'm paper download class. So I'm also doing this for the first time. My question first time mark 15. Is the ability to exchange information and communicate with internal and external applications and systems. What is that? Ability to exchange information and communicate with internal and external applications and systems. So that means between systems, maybe internal systems or even external systems, right? Right. Ability to exchange information and communicate with internal, external, okay. Integrity, interoperability, portability. Portability means, say we want to port it to a Linux environment. We want to port JDK, say X version to Y version. So that is called, this is not portability. Recoverability means when there's a crash, how well or how fast or how well we can recover it. Scalability means when more and more users are there, still our system can cater for those users. Interoperability means different systems, we must be able to communicate and collaborate with them. Interoperate different systems. So I think that is perfectly valid for this. Integrity means usually in IT, integrity. Remember in the database we have the integrity, referential integrity and stuff. So it usually integrity means it act like a whole. So when you have component, so they are properly connected together. They act like a whole. Right? Indirectly, this is correct. Oh, this is related to this, but this is the direct answer. Integrity means exchange information, communicate and internal and external applications and system. But I will go for the direct answer only, B. But examiner may take A also. Right? Multiple answers right? I will go for B, but examiner might take A also, but I will go for only B. Okay. 15. B with right? So the direct answer with the examiner. Maybe a lagging right? So direct answer with so that is B. Okay. 16. Which of the following these are not key activities of the requirement engineering process? Okay, that should be easy. Requirement elicitation and analysis. So analysis, right? So we break it down, we look at the big picture, we see how they are interrelated, generalization, specialization. Me requirement design කියලා එකක් නෑ. මේ examiner වචනයක් හදාගෙන හැමතැනම දානවා. හැබැයි ඔයාලට දැන් මීටරේ ටක් ගාලා හොයන requirement design කියන්නේ විකාර රූපී වචනයක්. Right, we have to validate the requirement. Okay, requirements are, of course, requirement evolution is naturally happening, right? Because the requirements may change over the time. But I don't know whether it's activity. Activity එකක් කියලා ගන්න ඕනද කියලා මම දන්නේ නැහැ. Requirement specification, maybe what the examiner means is documentation, right? Specify the requirement කියන එක වෙන්න ඇති සමහර විට, but definitely A correct, D correct. Usually requirement gathering, requirement analysis, right? Then the requirement modeling and the documentation and validation. ඔය ටික තමයි සාමාන්‍යයෙන් යන්නේ. Evolution එක ප්‍රධාන එකක් නෙමෙයි, හැබැයි එහෙම දෙයක්ත් යනවා වටින්. Requirement specification. Activity එකක් නෙමෙයි. Requirement specification is that document that we prepare. So I will go for A and D only. But examiner might take E. Okay? Examiner might take E, but I will go for A and D. Not අහන්නේ නේ. Not key activities. Key කියලා තියෙනවා බෑ. Key activities. I will go for B, C, and E. B, C, and E. E is the debatable guy. Okay? 16. I will go for B, C, and E. C and E අරන් තිනවා. Examiner B අරන් නැත. ඒ කියන්නේ examiner කියන requirement specification කියන එක key activity එකක්. So maybe the examiner has taken requirement specification as the documentation. අපි requirement document කරන්න ඕන කියලා. අතන requirement specification එක කියන්නේ document එකට. ඉතින් document එක activity එකක්ද කියන එක පොඩි ප්‍රශ්නයක්. So what they ask is activities. But the specification is not an activity, that is the final document. So that is why I didn't take it, but examiner thinks that specification is also an activity. Okay, that is debatable. I don't agree with that answer, but anyway, finally it is not my agreement or disagreement is not the issue matter. It is your examiner's answers. Okay, but anyway, we can agree and disagree on things, right? This is democratic country, right? And this is higher education, right? So we must have that open mindedness, right? And even you can disagree or agree with me, or maybe you can agree with the examiner rather than me. So that is fine. So that is how the society goes. Okay. 17. බැයිම agree වෙන්න නැහැ කියලා T50ක් කරන් එන්න බෑ. හරි. ඔළුවට වෙඩි තියනවා කියලා. හරි. අන්න ත්‍රස්තවාදය නේද? එහෙම වෙන්න බෑ. agree වෙන්න disagree වෙන කතා බහ කරගන්න පුළුවන්. එතනින් එහාට බෑ හැබැයි. හරි. දැන් ලංකාවේ ඒක එහෙම නෙවෙයි නේද? කාලෙන් කාලට T50 උස්සන් වෙනවා, බෝම්බ අරන් එනවා, agree වුණ නැති වෙච්ච එක. Right. Which of the following is are problems of requirement analysis? Problems or challenges. Right. Stakeholders express requirements in their own terms. Yes, it's a challenge, right? Because we may not familiar with their business jargons. It's a challenge. I don't know whether it's a problem, but I would say it's a challenge we have. Yes. Stakeholders may want the system as early as possible. Right? Is it problem of requirement analysis? No, it's a problem, but I don't think it's a problem of requirement analysis. Writing down the requirements take a lot of time. Yes, if you write in detail, yes. So that is why we want to write down those in a very simple, short manner, like user stories, okay, rather than put it into detailed documentation. Different stakeholders may have conflict in requirements. Yes, it's a problem. It's a challenge. Requirements may change during analysis process. Yes, it's a challenge for us. Okay. Right. So these are the two main challenges. But I think we may consider the A and C also. Problems. Problem the way. Problem කියන්න බෑ වෙන්නේ. I will go for A, D, and E. I will not go for C because they are same problems. සමහරට C ගන්නත් ඉඩ තියෙනවා, but I will go for ADNE මොකද මේක problem එකක්ම කියන්නත් බෑ ඉතින් ලියන්න වෙනවනේ කොහොමද නේද? I don't know whether examiner will take it, but I will go for ADNE. Okay, 70. Yes, ADNE. Okay. මොකද මේක problem එකක් කියන්න බෑ ලියනවා කියන එක නේද? ටිකක් කරන්න ඕන වැඩක් කොහොමද? Right? So therefore I didn't take it. Examiner has also not taken it. Okay. So therefore ADNE. So this is something we have to do, right? Anyway, so therefore we can take it as a normal, not a issue. Okay, not a issue, not a problem. It's generally we have to do. Right. 18. Which of the following should not be an actor in the use case diagram of a typical pharmacy management system? That should be easy one. Actor කියන්නේ user role එක. Typical pharmacy management system. Obviously librarian ලට කරන්න දෙයක් නැහැ නේද? Pharmacy management system එකක් ඇතුළේ මොකෝ බෙහෙත් ගන්න එනවා. Library member, QA engineer. Use case diagram එකකට QA engineer කෙනෙක් ඉන්න බෑ. Use case diagram means the functionalities, the use for possible usages of the system, right? That is beyond the development. So therefore QA engineer has no role in the use case requirement documentation. Use case, that is the customers, the pharmacy cashier, right? Any other sales assistant, manager. So those are the possible actors. System admin, maybe in case of backup and other situations, there's a possibility, right? Because maybe the user management and other things will take that. System developers also, we don't have to consider, right? I don't know. I don't like that. Again, my liking doesn't matter. It is your examiner's viewpoint ultimately matters, right? Let's see whether we have agreement or disagreement. So I will go for not අහලා තියෙන්නේ everything other than D. A, B, C and E. මේ දෙක ගණිත දන්නේ නැහැ. මම නම් ගන්නවට කැමති නැහැ. මගේ කැමති නෙවෙයි වැදගත්තා. 18. Right. So everything other than D. So that means it is same as my answer. Okay. So remember, so the QA engineers, developers, project managers in the band use case diagram, but ඒගොල්ලෝ software develop කරන කාලේ විතරක් ඉන්න පොඩි set එකක්. So use case diagram is all about your functional and non-functional requirements. Okay. And the librarian and library members are not relevant to a pharmacy management system. Thank you. And මේ librarian කෙනෙක් බඩු ගන්නවොත් කියලා එහෙම ගන්න කිව්වොත් එහෙම use case diagram වලින් ඉන්න වෙන්නේ නැහැ ඔයාලට. Right. 19. Which of the following these are types of checks that should be carried out on requirements during the requirement validation process? Now we are going to validate the requirements, right? So now we have documented the requirements with according to our understanding after our analysis. Now we want to, now we have documented that. Now we want to show it to the customer and validate. Before showing to the customer, we can do some validations. Maybe. So what kind of validations we can do? Now we have set of diagrams, right? Models. Right. So what are the type of validations we can do? We can check for consistency. Is this diagram conflict with this diagram? Right? If so, something wrong. Maintainability, I don't think maintainability has something to do with the requirement analysis. Diagram, so the documentation, right? Completeness, yes. Is it complete? Make make us completely තියෙනවද නැත්නම් කෑලි අඩුද කියලා බලන්න පුළුවන්. මේ ඒවා ඉස්සෙල්ලා අපි කරන්න ඕන validations. Adaptability, no, I don't think adaptability means when it's adjustment to the changes. So that is more into the software, not for the requirements. Verifiability, I think that is also good, right? When you write a requirement, when you document a requirement, that documented requirement must be verifiable. For example, if you write down a non-functional requirement, something like the system must be fast, then you make a test කරන්නේ. system must be fast. Then, so so it has to be written something like the search results must be presented within 5 seconds and verifiable with the requirement. So verifiability is important, right? When you are writing the requirements, right? So I will take that also. So therefore, my answer is which check should be carried out? Consistency, completeness, and verifiability. A, C, and E. 90. Yes, A, C, and E. Correct. Okay. 20. Which of the following these are not UML diagrams? Right? I told you that I will be sharing you the object-oriented SAD, not entire things, maybe just the overview chapter, right? So at the end of the session, I will be sharing it to both the WhatsApp groups, okay? Which of the following these are not UML diagrams, right? ER diagrams are not UML. Mama diagram note එක දුන්නා මට එක කියව ගන්න. Definite use case diagrams, that is the main UML diagram for the requirement analysis. A class diagram is the main diagram for the design. Yes, we draw activity diagrams. Interface diagrams. It's not a major diagram. Actually, there's nothing called interface diagrams. You have some other diagrams. Interface. I don't know whether it's a new one. Interface. Definitely not ER diagram, okay? The main UML diagrams are the use case diagram and the class diagram. Those are the two main diagrams. Then we have sequence diagrams, communication and collaboration diagrams, activity diagrams, state diagrams, deployment diagrams, module or the component diagram. So those are the main diagrams. So interface diagrams, I will not take, but I don't know whether something like that is there. I will go for, okay, I will be sharing that note after the session, okay? UML note, short, the first topic. I will go for A, C, and D, okay? Not ahane. So therefore B and E, right? B and E, correct, right? Our answer is correct. Not ahane. Nokata ilang වැඩේ exam එකට ගිහිල්ලා not ඒවට correct ඒවා ගහලා ඇවිල්ලා කියනවා වැඩේ දීමෙට දුන්නා කියලා. වැඩේ අන්තිමට හම්බ වෙන්නේ බබා හම්බ වෙන්නේ විසාසාව තමයි. දැන් මටත් ඒක නෙන්නේ දැන් not ඒවට මම මේක තමයි උත්තරේ කිරිත් වෙනවා හරි. But the real answer is B and E, right? 21. Which of the following these are not with respect to sequence diagrams? ඔබට ඊළඟ වැඩේ semester 3 වල තියෙනවා semester 2 වල අහනවා. මේකෙන් අර repeat කරන student ලට වාසි. හරි repeat කරන student ලට ඇත්තටම අපි මම paper එකක් ඇදුවොත් එහෙම repeat කරන student ලට සත පහක වාසියක් නොවෙන්න හදන්නේ. මොකද repeat කරන student ලා ඇවිල්ලා fail වෙච්ච set එකට. ඒගොල්ලෝ second time කරන කට්ටියනේ. second time කරන කට්ටියට මේ paper එක වාසි දැන් ඇයි ඒ? ඒගොල්ලෝ second time කරනකොට subject එක repeat නාට ඒගොල්ලෝ second level 2 ගිහිල්ලා නම් දැන් ඒගොල්ලෝ object oriented SAD කළා. ඒගොල්ලන්ට නෙමෙයි වාසිය දෙන්න first time කරන කට්ටිය. ඔක දැන් A level වලත් වෙලා තියෙන්නේ. හරි. A level ඉබයි කාලා ගන්න වෙන්න ප්‍රධාන හේතුව ඒකයි. සමහර එවුන් හතර පාර කරනවා A level. ඒක අවුරුදු 4ක් තිස්සේ කරපු එකත් එක්ක තරම් කරන්න ඕන අර පොඩි එකා. අවුරුදු දෙක first time ආපු එකා. ඒතර unfair. ඊට පස්සේ ඒකත් යන්න ඕන ඊළඟ අවුරුද්දේ A level කරා. හරි. එහෙම කරන්න බෑ. එකපාරක් කරන්න දීලා කියනවා දැන් ඕක තමයි ඔයාගේ තත්ත්වේ. කරදර කරන්න එපා. ඔයා දැන් වෙන වැඩක් කරන්න. ඕක බාර ගන්න ප්‍රතිඵලය කියලා නේද? ඒකත් මේ පේපර් වල ඒගොල්ලන්ට වාසි වෙන විදිහට ක්වෙස්චන් හදන එක ඉතා නරක වැඩක්. ඉතා නරක වැඩක්. මොකද දන්නා BIT කරනවා සමහර අවුරුදු 10ක් විතර තිස්සේ කරනවා. අපිට සමහරවිට මූණවල දැකලා එපා වෙලා සමහර සුළුලගේ. ආයි ඉන්නවා. හරි. So therefore, anyway, මේ වහනාන්ත මම ඔයාලට object oriented essay දී note එක දෙන්නම් මට ඉතින් note එකම දෙන්න වෙයි වගේ මේවට මේව කරන්නම් හරි. Right, which of the following needs are true with respect to sequence diagram? හැබැයි අපි මේ ටික අපි mention කරලා තියුණා design note එකේ යා. වගේ design note එකේ තියුණා. මෙන්න මේ හරි. System modeling වල මට මතකයි ඔය ඔක්කොම diagrams mention කරලා තියුණා කියලා. So this is මේටි mention කරලා තියුණා හරි. Use case diagram, sequence diagram. ඒකන්ද මේ question එක අසාධාරණ නෑ එක්තරා විදිහකට නේද? මොකද ඔයාගේ note එකේ mention කරලා තියෙනවා sequence diagram. So that is how the message are passed between objects. Right. Then the structural model, you have the class diagram. Okay, definitely that is the main structural diagram. Generalization, association, composition and aggregation. ඒවත් තමයි දැන් මේවා අහන එක එක්තරා විදිහකට වැරදි මොකද ඔකට ඔයාලට සබ්ජෙක්ට් එකම තියෙනවා ඊළඟ සෙමස්ටර් එකේ. නමුත් ඒක කරන්න දෙයක් නැහැ. In the behavioral models, so it includes the activity diagrams, state diagrams, state machines, so the state diagrams, how the state change from one state to the other state, blah blah blah. The activity diagrams done පුළුවන්. So then what is mean by model driven engineering? Lot of emphasis on modeling. So it started from rational unified process. Right? Lot of emphasis on modeling and designing before going to the coding. Okay, MDA. So there are three type of models. Computation independent models, platform independent models, platform specific models. Okay. So computation independent model means something like a state diagram, something like a normal ER diagram. Make a computation pattern. So then platform independent. It is a platform specific here. Now platform is decide Java, the .NET name here. So then of course finally they execute code. Because when we are designing, first we are not thinking about any technology. We just design it at the conceptual level, right? So then we decide on a platform, right? Whether we go for Java or .NET. So then we modify it according to the limitations, features, and then only we can do the coding. Okay, right. Which of the following is are true with respect to sequence diagrams? Sequence diagrams are not part of UML diagram. Wrong. Sequence diagrams are part. Not කියලා තියෙනවද වැරදි නේ? They have used to model the interaction between the actors and objects within a system, right? Interaction between you. පටන් ගන්නකොට තියෙන ගොඩක් කරන්නේ මොකක්ද? actor කෙනකින් තමයි පටන් ගන්න නේ. ඊට පස්සේ objects. නේ. ඊට පස්සේ objects තමයි මේ message pass කරගන්නේ. Yes, correct. Interactions between objects in a sequence diagrams are indicated by annotated arrows. Arrows වලින් පෙන්නන්නේ යන message එක තමයි නේද? මේ method message එක කියලා යන්නේ method එක. ඊට පස්සේ මෙයාගෙන් මෙයාට message එකක් යනවා. මේ annotated මම arrows හරි annotate කියනවා ඇති මේ නම දානවට. හරි? will take yes. They show the sequence of interactions that take place during a particular use case or use case instance. Yes, we draw a sequence diagram for major use cases. One diagram is for one use case. They are developed in the software implement. No, they are developed in the designing stage, not in the implementation. Okay. So we'll take true one. We'll take B, C, and D. Okay. 21. Yes, B, C, and D. 22. In object-oriented language such as Java, generalization is implemented using inheritance. right? Inheritance, generalization, specialization can look at the inheritance. So answer must be C. Ek semester 2 one yeah. C. The following diagram shows part of the class diagram of a company. So we did this in programming subject, semester 1. This is inheritance, right? So these are subclasses of employee class. Values that A and B can take are, so then they must be special case of employees, right? Manager, yes, right? Manager is employee. Owner, then business owners la employees la venada. Nah, neither. Owner employee කෙනෙක් විදියට managing directors ලා එහෙම කියලා ඉන්නේ. But in general owner is not නේද? අපි බෙදන්නේම employer employee කියලා. නේද? Employer තමයි owner. So therefore will not take it. So you have to use a bit of common sense, okay? Customer is not a special case of employee. Customer is a different concept. Cashier, yes. Sales executive, yes, sales executives are employees. So the possible values are, remember managers are employees, managers again owners again. We'll take A, D, and E. It's a bit of common sense, right? A, D, and E. According to UML notation used in the following diagram, values that X and Y can take are, right? Values that X and Y can take are engine, so that means special cases we need. No, car is not a special case of engine. Petrol engine, yes. Piston is not a special case of engine. So piston can be, if this is engine and piston is something like this, composition, yes. So piston is part of the engine, not special case of engine. Diesel engine, yes. Spark plug, no. Petrol engine and diesel engine. 24, B and D. Right? Which of the following is are not a part of 4+1 view model of software architecture? 4+1 view model එක කොයි හරි තියුණා මට මතකයි. බලමු අපි මතකින් කරන්න ඉස්සෙල්ලා. මට හරියට මතක නැහැ කොතනද තියුනේ කියලා. හරි. Logical view, process view, product view, development view, design view. මට නෑ ඒක ඔළුවට එන්නේ නැහැ. හරි. බලන්න කොහෙද තියුනේ කියලා. 4+1 view model එක. modeling වල තියෙන්නේ නැත්නම් බොහෝ විට. කොහෙද තියුනේ ටක් කරලා මතක කෙනෙක් කිය. Lois it take time. එතන තියුනේ නැද්ද? maybe requirement. වැඩි තියුණා වගේ මතකයි යා. Can't remember. කොයි හරි තියුණා හැබැයි යා. I can't remember. ඒක පොඩ්ඩක් ඩබල් චෙක් කරන්න. මට මතක නැහැ උත්තරේ නම් මොකද මට මතක නැහැ views ටික. Right. What is the answer given? 25. C and D. So not a අහන්නේ. කියන්නේ මේ දෙක අදාළ නෑලු. අනිත් ඒවා තමයි එතකොට software architecture එකේ views වලට එන්නේ. Logical view, process view and development view. Right? 26. Right. MVC. MVC අපි දැන් කතා කරගෙන යනවා ටික ටික නේද? වෙබ් වල කතා කරානේ MVC architecture. The following diagram shows a web application architecture using MVC pattern. X, Y, Z. ඔකලා අහන්න ඇති මොනවාද model, මොනවාද view, මොනවාද control කියලා නේ. හරි. බලන්න. So view is, now when you say someone, now this is for web application, okay? So the database communication is done by model, and initially your request is taken care of by controller. Then controller will contact the model, and model will communicate with the database, and that data will be push it to the view, and that view will be sent. So that is how it works. Your request is taken care of by controller, then controller gives call the relevant model. Model will communicate with the database, and the data will be pushed to the view, and the view will be sent to the UI. Again, there will be another request of a page or maybe submitting some data. Again, controller take care of that and pick the correct model, blah blah blah. It up. HTTP request processing. You can make a boho with a controller. Application specific logic and data validation. So that is pretty much controlling. Okay, controlling. Business logic and database. Database with a model. Model. So mail controlling part. Then dynamic page generation, form management, views. Form to display. So refresh request, change notification. So we are notifying the view. An update request is coming from controller to the model. So the XY is a controller view model. Controller view model. D. Yes, D. Question clear? Right. Any question? Yeah. Right. So we'll finish the rest of the stuff next time. Maybe Thursday class before moving to the paper database paper maths paper web Friday night and Saturday. Right. We stop at this point. Right. Thank you. I will be posting that object-oriented note at the after the session. Okay. Right. Thank you.